All right, where are we at here? Let's make sure that my audio's good. Looks like you guys can hear me. Looks like my video's good. You guys should be able to see me. Well, here in a second you'll be able to see me. All right, let's go to streaming. All right, so what are we working on here? They're sending grounds. Hey, I figured you guys were finishing up down in the Discord, guys. We had a really good session. They were down there working on getting better at interviews, and there's kind of like this in tech, especially for people that are not yet in tech and have not yet like sat at the helm of an operations for like a team or something, where people, you need to get some confidence. You need to feel comfortable that like, hey, I can do. There's a certain. I actually really like it. There's a book called Programming Perl by Larry Wall and Michael Christensen. I have it over there. But one of the first things they talk about is like the hubris of an engineer, and it's something we can't teach. Like I can't teach to you. All I can impart to you is that you will have it. Like it's almost like you will have it when you have it, but you will have it when you start believing that you are an engineer. It's almost like a self-perpetuating thing. And what I'm saying about it is there's a hubris to like we're in a meeting of like 20 people and they're all kind of like little penguins up on a, and I'm just like, fuck it, throw my screen up, let's do this, let's get this thing working. Somebody has to jump, somebody has to like take control of a situation, and that's actually something that's benefited me well. I don't care if 100 people are watching me, right? I don't care. Like if I know what I'm doing, if I have like correct context for things, and if I already know the system's down, shit, like there's a certain amount of hubris to it. But there's also, that can be tempered. That doesn't just have to be like, oh, I think I'm the big buck of this lick, like Abraham Lincoln said, right? No, it doesn't have to be like that. It can just be more of like there's a certain amount of hubris too, that I tell people, like when I look at something that somebody else engineered, I go, this guy made this as simple, this guy or gal, I guess, but this person made this as simple as they could make it. They made it as simple as their mind would make it. Because I've never known an engineering step. I've never in my career seen anybody build anything and then go, now let's make it harder. Let's make it a little more complex to understand. No, the anything that's been engineered is probably as simple as it can be. But yeah, they just finished up. They were doing interview and prep mock type stuff. So I thought that I'd mention that. This right now where I'm at, I'm on the second part of like my. Well, the wife's coming home from Cheyenne today, so she's flying back. I got a few hours here. Did my college stuff with my students earlier, hung out with the guys a little bit. Now I'm on here. And what I'm doing is I'm just cleaning up the lab environment. I'm making sure that it still works with all the stuff. So if you say, hey, where's unit 1 through 4? Well, we did that earlier. Now we're doing 5 through 9, which will presumably be the end of the labs. You get to see my Bastion process a little bit, right? I've cleaned up the Bastion, so now you go into the admin or the security engineering or the automation course, and it'll drop you directly in there. I drew that all out the other day, right? Like what that process kind of looks like. It's all over here. So for people, as like a quick review, what the environment kind of looks like, it's something like this, where you come in from out in the world. Don't worry, those are drawings by other people. If you're admin, security, or even the new course, which is going to be automation, you just come in with Prolog at prolog.asuscom.com. You get connected in. You go in through our Jumpo 2 server, which is not a woefully behind the times Jumpo 1 like my old poor little decrepit server. And this guy is Rocky 9, and he's much more updated. And then it drops you back into like either the Rocky or the Hammer, or now the Auto backend, right? So those backends are all built and defined. And the way that the jail kind of works is something like this. You get dropped in, you come in, you drop into our environment, you get dropped into a user jail. That jail then just sends you to admin labs, security labs, or automation labs based on the capacity of our environment, right? Let me move this back over. And the capacity of the environment kind of looks like this, at any time, bang cat. And I would see that currently there's an Ansible playbook that runs every minute, and if you guys wanted to see it, we could. But it just goes and it finds which ones don't have anybody logged in currently. And so in this case, Rocky 1 and Rocky 1's in use, and Rocky 3 is in use. However that happened. 2 cleared up, so it's back in there. That's the first one you're going to get if you check that you want to go to the admin course. Then a minute later, that one will be gone and it'll be pulled out. Yeah, there's a little bit of time in there for a race condition, but I'm not really too worried about that, right? We're talking about logins over the course of days. So Hammer, there's some people down in the security Hammer course right now, and we can see exactly how people logged in. Some of you guys were around yesterday when I was setting up. I set up Prometheus and Promtail on these, so now all the logs are going off in real time, right? And then the automation course, most people don't even really know about, so the automation course is completely empty. And then you also get kicked out if you don't do whatever you're supposed to do. All right, so that's all to say that what I'm doing in the lab environment is really just running through the course. And then I thought I would pull up a little bit because in the early part of the day, I was just going through the course, right? We're just doing hands-on. You guys are welcome to follow along with me. This is free. You could do it on your own systems. You could do it in the Prolug systems. If you say, well, how do I get in the Prolug systems? Well, you go down to the Discord. You go drop into the Prolug. Lots of people have been talking lately for the course because the admin course ends today. And you go in here and you find you can drop in your public key. Yeah, only ever your public key, right? Never your private key. You can drop your public key in here and I'll go add it to the information. And then some of my testers have the other information. But yeah, if you drop your public key in here, I'll go put it in there. And people have been testing that. I know that it works. So, all right. Anyways, so without talking too much more about it, this week's Unit 5, the next one I was going to work on is repos and lab patching. So, or repos and patching. Like how would you take a fleet of servers that you had and move them forward a version? How would you, man? And it's almost, I'll tell you, like patching servers is almost like moving a puzzle. Have any of you ever tried to move a puzzle? Like 500 of the 1,000 pieces are in place and you try to like move it from one table to another, you're not going to have very many things in place. You're going to have to, so there's some planning involved. There's some considerations involved for how we do it and stuff, right? So that's kind of what this week's about, or this lesson here that I'm looking at now. It's got some stuff on Stigs, tells you to go get the Stigs, and then it talks about maybe updating like your Linux InfiniBand drivers. And I have this little activity for you guys to do in the lab where you come in here and you say, hey, I want to download a version, right? And I want to get it for Rocky. Maybe I want to find a Rails CentOS Rocky box, and I want to go to this version of a long-term support, and maybe I know that I'm on Rocky 9.6, and I know that my architecture is x86-64, and here's the Mellanox OFED drivers that I would use if I had like ConnectX cards in my system, and if I was going to be doing high-speed networking over InfiniBand or something like that. That's typically what this type of stuff is. But if you've never done that before, that's like a good little practice. And then you could download that. I don't make them actually download it in the lab, but that's, you know, the driver then has to be, once you've downloaded it, it has to be compiled for your specific version with your specific kernel headers. And this actually is where, you know, this is where, you know, and it's unfortunate that I had to learn this in the trenches, but this is where you go and you kind of get these skills that are valuable, where I know how to then deploy those, and there's two ways you can do it. You could either spend the 20 minutes per machine compiling it per machine, and that's probably better if you have like 4 or 5 different types of architectures or machines out there. So I used to work in this like Frankenstein's monster type cluster where they had all these different components, so I would build those. I would spend the 20 minutes during my patching process to build them. However, if you're in a clean environment with like one version of something and they're stateful nodes, not stateless nodes. Stateless nodes makes all of this infinitely easier because then you just do it once and you push it everywhere. But in a stateless, in a stateful environment, and you have to do it like that, sometimes it's better to build the RPM package. So you come down, you compile it on your machine, you build the RPM package there. That RPM package just goes and gets installed on all your servers because they're all the same configuration and backend ConnectX card and kernel and all that stuff, and everything's going to be good because it's built for that specific one, you know, purpose, I guess. But that is a lot for some people. That is a lot to think about. Anyways, I show you that because that's a good way to kind of look through versions and stuff like that. If you needed to do that, see what the process might have looked like to build that. All right, so here's in the lab. Excuse me. And really, we're testing the lab out. This lab is designed to have the engineer practice deploying patches in a Linux environment. Fair enough. We've got software that we trust from somewhere, maybe some vendor repo or something like that. And the engineer is going to create repos and then deploy patches through an automated enterprise level Ansible playbook. That's at the end. And then, but first, the engineer will review the Apache 2.4 STIG requirements if they want to run their own repo in the network. So the STIGs, if you guys remember my STIG viewer, I know it's a little bit of a flashbang, so cover your eyes. The STIG viewer, maybe that we need here, so I'm going to close without saving, is the Apache 2.4. And the Apache 2.4, if we generate a checklist from it, there are 47 things that you could harden about an Apache 2.4 deployment for your system. So I might bring this over here. And again, we just kind of review them quickly. STIG 214234, so 214234, is about Apache web server must use logging mechanism that is configured to alert the information system security and system administrator in the event of a processing failure. So this thing has to be configured to send logs with like a SIEM, your security and information event monitoring, right? Just of what's happening in the environment. So how could you do that? Well, you could be sending your logs through like syslog to some device, and then that syslogger is going to be configured, or that syslog centralized location is going to be designed to send information in, and process errors that come through. Or it could be going to a tool like Loki, and then Loki could be catching it, and something could be watching Loki for, so many, 400 errors coming through, right? Local internal 400 errors. There's a bunch of things that you could probably track on. But the point is that has to be being done. So going back to our talk from earlier, if some of you remember it, what type of control is that? If I am turning on something that is going to, let's just think about it like this. Is it physical? Am I physically doing something? No, it's inside the system, right? And it's not like I'm putting like an iron bar up to make something happen. No, so it's not physical. Is it managerial? Like it's coming down from management, like it's being directed to us? No. Is it operational? Like is it a standard operating procedure? Not really. So it's a technical control. Technically, we're turning on the flow of bits to go to some place. So it's a technical control. And then what type of control is it preventing something from happening? Not really. Is it deterring somebody from doing something? Like is it like a splash screen or a message of the day? No. Is it corrective? Does it fix something? In some ways it does. Is it compensating for another control that can't handle it? Not really. And is it directed by somebody? No. It's much more of a detective control. Logs are almost always a detective type control. So yeah, it's a technical detective type control, and that's a question that I have over here. Type of control is being implemented. So that's what we're doing, right? Apache web server must use logging mechanism. And then 214248 is right here, and it says the Apache web server application directories, libraries, and configurations must only be accessible to privileged users. Well, that's a permissions thing. So once we put Apache on here, we might make sure that it's controlled. So let's do that real quick. Let's say www.ctl, systemctl stop www client. Right, so we'll stop the client. Then we'll do dnf-y install HTTPD. So we'll install the HTTPD server. And the areas that they're talking about for configurations, I should have it right here. If they don't have it, it's under etc HTTPD. And if I ls-l in here, I see that they're all owned by root. These are links down into other places, so that's fine. But these are all owned by root, but they can be read by other people. So they can be read by other people. Okay, let's go down into conf.d. And in here, here's the main one. So this one is, what is that, a 644? So it is readable and writable by root as a group, and readable by world for everything else. But this thing says, Apache server applications, directories, libraries, and configuration must only be accessible to privileged users. Limit exposure to any adverse effects from that. And ownership must have permissions and ownership set properly for only that. So we might have to verify what they mean. But then down here, ensure non-administrators are not allowed to access the directory tree, shell, or other operating system functions and utilities. So this right here is telling us that everything under etc httpd really shouldn't be read by people outside of here. So this is probably going to have to go to like a 640, because only admins will have root as either their actual user or root as their secondary group, right? So we'd have to change this in some way. And that's just, that would be a technical, where's that? That would be a technical preventative control, because we would not be letting anybody in there, and we would actually be blocking them through technical means, right? So technical preventative control, okay. All right, so then we get into kind of the lab. So that was just some stuff to make you guys look. There's 47 other total, what is it, 47? Yeah, there's 47 things that you can check and harden and clean up. Most of them are dealing with TLS in some way, but that's good. All right, so let's go clean this up. CD, I'll clear the screen. CD to etc yum.repos.d. And in here, there are a whole bunch of repos. Look at all those repos. And I'm going to make dir old archive. That's one I like to do. And I'm going to move everything.repo into old archive. Everything's gone. So there's nothing in here anymore. You guys just saw a few seconds ago I did a DNF update, or a DNF-y install HTTPD, and I went and pulled all those repos. I can't do anything with DNF anymore. DNF has nothing for me. So then I come down here, and I'm pretty sure I fixed this. So let's make sure that I can mount this. So mount-o loop will mount an ISO, if you guys have never seen that before. And I'm going to loop in lab work. And then we're going to do repos and patching. And then Rocky 9.5. Yeah, so I picked that exact version. Even though we're up on Rocky 9.6 now, it'll be fine. And, oh, we got to mount it somewhere. To mount. I wish I could type. So now it's mounted. So if I do a df-h, I'll see it mounted as a loop down in /mnt. So let's go look at what's down there. By the way, most people don't mount things directly to mount. They'll do like a subdirectory, but that's fine. We're just, it's a lab box, so who really cares? I would like to note that, though, that you normally won't put things directly on mount. You put them down in like mount ISOs or something like that. But for now, let's cd to mount, and let's see what's in that ISO that's been mounted on our box or our server. There's AppStream base OS. That sounds like the other repo stuff that I was looking at earlier. And I can go ahead and back in my etc yum.repos.d right here, I can touch etc yum.repos. Oh, we're already in there, so we don't need to do that. Rocky 9.repo. And in there, vir Rocky 9. I think I have that as an absolute path because I don't know where you are going to be in the operating system. Let's go grab this. And as we grab this configuration of two repos, let's see if we can't understand what's happening here. Well, there's the basically the beginning of the configuration for base OS and AppStream. Okay, I think we can get that. There's a simple name. Doesn't look like name cares if you have spaces or not in it, so cool, we got the name. We got metadata expires never, right? -1 typically means never. We are going to need a GPG check, so we are going to expect this file to be there. That's fine, it should be there. And then it's enabled, so it's turned on, yes. And then the base URL is file, and then we have 3 forward slashes, mount base OS. Now we did see a base OS, and we did see an AppStream. So inside of those must be the metadata that we need, or repo data, to be able to configure this repo. Specifically, we need the repo md.xml. Right, so those are in there. So this should work. Okay, and let's go ahead and we saved that already. And let's real quick, we're going to chmod. Whoops, just so it can read. Chmod 644 etc yum.repos.d, and then that Rocky 9 repo. So if the ls-l etc we're already in there, it doesn't matter. It's already there. So we're 644 on it, so it's readable by any process in the system. And let's say DNF clean all, just to get rid of any messiness that's out there, any cached metadata and that kind of stuff. And let's do a DNF repo list and see if our system can see any repos. Well, the only repos that are configured right now are that app stream that was local on our system and the base OS. Those are the only two that could be configured. We got rid of all that other crap. Okay. So now we see that they're like that, and then let's go ahead and disable one just for fun. We're going to disable DNF, disable repo. And you might ask me real quick, hey Scott, do you think, you know, we've got that over here and we're typing it in every time. You might say, Scott, do you really need to do that every time? Do you really need to type it out? No, you guys, you could probably get away with, really, you can get away with copy and pasting it. But I would posit this: if you want to remember it, if you kind of want your fingers to do a little bit of walking as you're trying to remember how things work, do a little bit of typing it in. It's good for you, right? Maybe your typing sucks and you need to get better at typing, right? Like, I don't type nearly as fast as I used to, but let's type in a NL to give. This will give us the number lines. So there's 5,363 packages there in that app stream. That's a lot. And then we can also, if we wanted to, look at the head of that just to see what's at the top of that. And it gives us that maybe there was a couple of lines that were already used. So it's 5,361 lines of actual software or whatever, right? Because this is one line here and this is one line here. All right, that's kind of cool. And then maybe we switch that over and we change this to something like base OS, right? And maybe on this one, it gives us the actual number lines, and the base OS has 850 or so, you know, minus a few. But those are all the ones local to this machine, or local to this ISO that we've mounted. So we mess around with it a little bit, and then we get tired of that, and we say, okay, let's try to install something. Let's do DNF disable repo equals all, right? That's, we're going to delete everything, get all the repos, not delete them, but get rid of them. And we're going to enable repo base OS, oops, enable repo equals base OS and app stream. And then we'll install GIMP. Let's see if GIMP is out there. And let's see what requirements there are for GIMP. It's 173 packages. Say how many megs it is. 123 total new megs on our box. Maybe that's too much. Oh, the install size is 481 megs. So that might be too much for us. Let's say no for now. And then let's say df-h. Do we even have that much space on this box? TempFS thinks that we have 1.8 gigs available, so we could afford it, but it would be costly for us as far as how small this box is in general. That's a reminder. Hold on. That's a reminder. In my in our lab, we need to fix the TempFS size. I've got this over here, right? Fix the TempFS size for the Hammer, Rocky, and Auto boxes. So for TempFS to get fixed, that's going to require me to add in a kernel command line argument. So I'll do that. I'll do that on Sunday night. We have maintenance coming up. So basically, I'm just going to use Sunday nights for maintenance for guys in the Discord, right? By the way, the interview prep is pretty much done. I saw Sending Grounds here, so I'm pretty sure that that's pretty much done. But okay, the wife's flying home. Late night bash study group. I'm going to run that at 10 p.m. tonight, so we'll be doing some bash if people want to do that. We'll do my lab maintenance will be on Sunday night though, and I'm going to do that just so that I think people will benefit from seeing maybe like some of the lab maintenance stuff that you might be able to do if you had like a change window and a downtime and planning and that kind of stuff. And then you guys can kind of see the way that I do stuff. Although Granted, in my home lab, I do things a little more tongue-in-cheek, and I just do a little more shooting stuff from the hip than I normally would. And also, guys, we have officially said that we will start the security engineering course round 2 in 1 month. So 1 month from now, it'll start on September 20th. So you guys are welcome to come to that. We have capacity in the labs. We also have a lot of the stuff recorded, so people can start studying it now if they wanted to. And really what we're doing now is just kind of working through the labs to make sure they all still work. So, okay, so I've done all those things, and I feel pretty good about that. I'm going to do an RPM QA grep for HPD. Make sure I have HPD in my system. Yep, I do have it. I can do a system CTL status for HPD, and I can see that it's dead. Oh, it's dead. And then I can do, if I needed to, ss-ntulp grep for port 80. You don't need the -i, it's ignore case. I'm just so used to it. Port 80 is not running by default on my system. Okay, okay. And maybe, maybe what I might do here then is turn it on. So I might say system CTL start HPD, and then go back and look, and there is port 80. I can also do, one of my favorites is LSOF-I port 80, because, what? Oh my gosh, no LSOF. And by the way, this is going to use the local repo now, so we're installing LSOF. I got to put that in the image build. Hold on. To do add in LSOF and image. Okay, so I'm adding to-dos as I go over here. I know you guys can't see it, but I will make sure that we have that in there so that we know what we're working on. All right, so come down here. Now, the next thing I need to do is cd to etc hpd and then conf.d, right? And in here, there's a bunch of things that are kind of configurable about our system, and we're going to make a file in here called repos.conf. And this is going to then be, it's two directives, and then I'm not actually sure what an alias is considered. It's not a directive, but these little things that you do anytime you build something in a web server, we tend to call it a directive. So even though it's a directory, and don't get this mixed up, it's a directory directive in that sense, but it says directory mount /mount, and then down here we alias repo to mount, and then we allow repo also to go out. And the reason I'm doing that is because it'll be much more clear then that somebody's going to /repo. Most all of your DNF and yum look for /repo in the path, right? That's part of kind of how they look for their configuration. Well, by default if they're hitting a server, but we're going to configure it. We're going to hard link it all, so it's fine. Point is, this is the thing that we want to add, escape:/WQ, and we want to then systemctl restart HTTPD, and that's going to restart our service. Should be clean. And then we're going to vi our etc yum.repos.d Rocky repo, and we're going to change these base URLs. We're going to change them from file, like it is, to, we're going to comment out those other ones. So we can do it like this if we want. Oops. And then one thing that I might do is I would say YYP and then delete it. And then maybe another P and then delete it, right? And then now we're going to go modify these to have the right values in here for that path that we expect. So we can go to http:/25, and then it's got to be your hammer. It can't be, you can't be hitting hammer 25, but you're on hammer, so you got to use, it says right here, edit this file with your lab's name in the base URL. So we're on hammer 2, right? There's hammer 2. And then down here, we're going to do the same thing. And we're going to modify two things here. We're going to modify that path at the end and also the hammer. And the path here will be to app stream. Now, at just face value real quick, it makes sense that that's what we were just using. Hammer repos base OS and then hammer repo app stream, but we were doing them directly inside the machine via the file. Now we're doing them via HTTP and admittedly connecting back to our own machine and being able to see that configuration. So just if you close your eyes and think for a second, it's still the same exact repo. It's just now your machine is going out and connecting back to itself. Which, by the way, once you can get that to work once, any number of machines can hit this as long as they can hit it. So this machine could very quickly become the share facility for your whole, I don't know, list of servers or whatever. There's one major problem to that, though. One major thing I would say to think about, and this is one of the reasons, like people, if you ever see, there's a movie called Megamind. I really like Megamind, and he's like, you'll never be a supervillain because the difference between a villain and a supervillain is presentation, right? And he's got this whole big, I love it, but I loved Megamind. I thought it was great. Me and the wife both loved it, but the reason I bring that up is because the difference between like an admin and somebody just has root in an environment is like presentation. Like the admin knows, the engineer that's built these things knows the implications of why you take these things away. If you build something like this in an environment, right, and then you point all your nodes at it, and then this is down when patching goes, nobody's getting patched that night. Not until somebody goes in and rips out all that bullshit that's pointing to it and turns it off. So you'll have, like, this is one of the reasons people think we control root in engineering and administration because we're assholes and we're the only ones that are allowed root. No, it's because other people don't think to keep the system active. That's not their primary job. Our primary job is to clean up the system and let it always be ready to go. Well, other people will just, and I've had devs do this before. Devs before me got a hold of root, and in environments they would have these little rat nests of fucking repos, and then you would have to just scrub everything out. We actually had a playbook that went in and did what I just did, moved everything into old archive, patched everything, and then put all their junk back at the end of our patching. That was actually something we used to do. It only pointed to our internal satellite server, and then it could point back to all their junk when we were done with it. But not while we were patching, because anything in here broken breaks everything. All right, anyways, that's me on a long rant. But we've got our system now set up for patches. Let's do a DNF clean all. And let's do a DNF repo list. If we are still pointed to anything, we are doing that through those repos, right? We're doing that through those repos that are shared out from Hammer 2 repo appstream. And it's very important that you fix that in your own system. Don't do Hammer 25 there. Hammer 25 doesn't exist anymore, right? So now we try to install something. We can I can copy the command or I can type it. I can actually just, we could do this. We could do Control-Shift-R GIMP, right? And GIMP is right there. So I can try to install GIMP. And I'm doing it again over when I do Control-Shift-R, it pops that thing up. There it goes. Got rid of it. But no, that's the same exact thing. Same repo, same 173, same 123, same 481. Everything's the same. Which makes sense because it's all pointing to the same original location. So that is a lab on like removing all your repos, building a local repo off of an ISO, right? Because again, it's just a locally mounted ISO. Then taking that and going, okay, that's fine, but I want to share it to everybody. So I first off, I share it out through HTTPD, and then I connect back to myself, and then I do all that. So we did all that in one lab. That's a lot of, if you go look at that, that's a lot of stuff to kind of process if you've never done it before. It's very straightforward, right? Like the commands I did, I don't even have sleeves on, so I couldn't hide anything up my sleeves if I wanted to. You guys can definitely do this, reason through it and get it working. But now what we're going to go do, put that lab away for a second, and we're going to go out to Killer Coda, and we're going to do this other lab. And this lab deals with enterprise patching. Maybe a little bit around enterprise Ansible patching. So yeah, this is going to drop us in there. It's going to install Ansible on the box. And this comes from we're going to actually pull something out of Git that I wrote a long time ago, and then I just kind of add to it whenever I need to. And I don't really use it for anything professionally, but it's a enterprise Ansible patching lab. Set up your environment to work with the rest of the lab. And what's going to happen is when this is done installing the scenario, which is going to put Ansible on the box, we're going to go and we're going to answer these questions. Look at the roles in the order that they are run in the playbook. Does it make sense how the custom facts are used? What other custom facts might you use? What are the pre-checks doing, and what other ones might you add? And what does the reboot task do, and how does it check for the reboot to be needed? So I'm asking you a few different things to think about there, and I kind of want you to hold those in your head as you do the lab, right? Yeah, that's fine. Okay. Come on, system. Drink some water while we're waiting. I was telling the guys earlier, I just ate a whole bunch of Payway. I found out a few weeks ago that they'll deliver to my house, and I didn't even think I liked Payway too much. Like, I was like, whatever, it's a sugar chicken, just like orange, Panda Express, right? But they got this little honey seared chicken that's pretty good. This is the longest I've seen a Killer Coda take to stand up, so maybe it's kind of busy. You guys will find a public repository of mine called HPC Deploy, and I always intended to use this one more than I ever have, but we're going to download that, and then we're going to go in there and we're going to look at what's going on inside of this set of playbooks and stuff. When I think about patching, I always think of this. Like, if you guys have ever seen a Plinko machine, this is exactly how I think about patching. I got one of these, like, I got a Plinko machine GIF. I need to put this in one of my labs or something. Yeah, this is like a little Plinko machine right here. Little guys just fall down, and this is exactly how I think of patching in my head. At the start of a night, you give me 1,000 servers, and they are going to be configured, and they're going to be set up all these different ways. I have no idea what's going to come out of those gates. I have no idea what kind of bullshit state you're going to have your servers in. I'm going to check them. I'm going to test them to make sure a whole bunch of kind of base things are there that I need. And then I'm going to move them into individual patching groups. And if something happens to trigger that it's not supposed to be in like a week 2, or we have all kinds of patching groups, let's say, in an organization, and maybe something's in patching group 3, but tonight we're only doing patching group 2. Maybe I've got to flag that and take that off to the side and offline it for, clarity from the teams and all. There's all kinds of things that we might do to try to make sure patching doesn't take like real customer facing downtime. But I do think of it like this. This is exactly how I think about it. You can pour in whatever you want in the top of this, and I want to try to get as many things as I can moved through the system as I expect them to. And what I always call that is I call it painting with a wide brush. I want to hit the most number of, like if I can hit 95% of the servers with my patching and only have 5% cleanup at the end of the night, you might say, well, Scott, that out of 1,000 servers you keep talking about, that's still 50 servers. Yeah, but 50 servers with me and like 5 of my other people on call, that's not, or not even on call, but like we're all hands typically for like prod patching, that's not bad. Not to mention, the problems tend to fall into only 1 or 2 different types of things, and you've already eliminated a good number of the ones by checking up front. Like if you check that your RPM repo is working, like if you make sure that your your RPM database is built and there's nothing wrong with it, that solves a lot of patching problems. If you make sure that your systems can connect to satellite and download even just the metadata before you start patching, you're going to save yourself a lot of trouble. And one of the ones that I always check, and this is huge, this one, I had to learn this one the hard way, so if this helps anybody out and they don't have to deal with the shit that I've had to, please believe this is worth it. I always check to make sure the servers are up before I ever touch them. And you say, what do you mean by that? You give me a list of 1,000 servers, and I go and I check them, and 983 respond. Those 17 that didn't respond, I don't go try to figure them out. They're out. They're out for the fucking night. They're done. They weren't there when the subway train left the station. They were not there. And the reason I say that, and you say, well, that sounds pretty simple. Yeah, trust me. Because there's nothing worse than getting to the end of the night and having 1,000 servers to report on, and there's 17 that are down, and you're like, shit, were they down before we started? Who's got the record? Nobody's got the record, guys. Your screens have scrolled. You have jumped back and forth between different screen sessions. There's nothing that's gonna ever get that information back. You have to check it up for. It's like I tell people, it's the same thing with inside of a system when somebody's like, "Well, what was the memory doing 5 minutes ago?" And I'm like, "I don't know." There's a great scene. There's a great scene from a movie that some of you are gonna be like, "God, Scott, that movie's from 1999." It's called Pitch Black. Anybody here ever seen Pitch Black? Right? It's an old one, and it looks clear. Do we got a GIF for that? Hold on. Is there a little GIF for that? Where the guy's like, he says, "Is it clear?" And he goes, "It looks clear." And the guy goes to walk, and the alien comes out, and he goes, "I thought you said it was clear." And he said, "I said it looks clear." And that's like this. It's one of my favorite scenes in those type of movies because he's like, "Looks clear," and that's like a your mileage may vary as an engineer. Like somebody will tell you, like, "Oh man, this thing works for me every time," but your mileage may vary. It's the ultimate like throw off. Like it might work. Who fucking knows? Man, I saw Pitch Black on a break from basic training when I was in the Army in 1999. I remember going to see that. That is an old movie. But anyways, yeah, he looks in and he goes, "Looks clear." So the guy starts to go and the alien comes by him and he goes, "I thought you said it was clear." And he said, "I said it looks clear." And then he looks again and he goes, "How's it look now?" And he goes, "Looks clear." Great scene in a otherwise pretty violent movie that I actually really like too. I should probably watch that again. Anyway, so let's pull down, let's get cloned down this HPC deploy. It's just an open repository. And then in here, if we cd to HPC deploy and just look at what's going on in there, there's a whole bunch of stuff that I've just kind of built that's going and calling different roles. And the one that it says to do for this lab, it says to just run this little environment setup. So there's a little environment setup at the beginning. We'll go look at it. But it's package update, or install. And this is going to go, and we'll go look at what it does. We'll go examine it a little bit. And it says that there's some web and app, so it skipped node 01, so it's installing Apache 2 on this other server, so it should be on control plane. And then the other thing that gets installed, it'll be on the other server. So we'll watch this for a little bit. We'll see this for a minute or so here. And this is just our setup, but then you're going to see some stuff that happens. Yep, so that was on the one side where it set up Apache. And then on this one, I think it's MariaDB is the other one. Yeah, so we're assuming a web server and a database server. That's a common set of tasks for servers. And then also there's typically app servers in there somewhere. App servers are going to be pulling down your software and your versions of things sometimes. Depends on also, I mean, a lot of this depends on, are you doing stateful nodes? Are you doing stateless nodes? Are you connecting back to storage? A lot of things to think about in your organization. In fact, we just had a little talk about this the other day. One of our guys asked us. So we pushed some facts over to each of the servers. And let's go read those facts real quick. And there's two ways I can think to do that. Did I not give you that? Okay. Let's do this real quick. It pushed those facts over there, and those facts are from some template files that we have. But I didn't give you the playbook here, so I'll show you how to do the playbook real quick. If we look in here real quick, there's our host file, and it's control plane in node 01. So check this out. I can say Ansible servers -i host, so it'll use this host file in here. And I'm going to say -m shell -a, and we will say cat. And what was that path up there? It was Etsy Ansible facts.d, and then patching.fact, right? And if we run this against those two nodes, it's going to tell me that node 01 got this information pushed over to it, and node 02, control plane, got this pushed over to it. So control plane and node 01 responded. By the way, they didn't respond in the order that we asked them. They just responded in whatever order they came back in. That's true because Ansible will, you ask Ansible something 30 times and those nodes will come out of order every time, right? The only thing, there was a question earlier actually, Sending Grounds, I don't know if Colchis ever got it, but it was forking. How many forks of Ansible are you going to allow the system to send out? And by default it's 5 right now, but we can change that, and you can go up to hundreds, but there's some there's some considerations there. And actually, I was like champing at the bit. It's champing, by the way. That is the right term. Chomping means you're biting through something, right? Champing, horses champ at a bit. They don't chomp at a bit. And that's actually one of my pet peeves when people say that wrong. But anyways, also because my last name is Champagne, so it looks like that. But anyways, it's not champagne. It's champagne. It doesn't matter. This thing even can't do my name right. But anyways, champing. I forget where I was going with that. But these servers. Yeah, I lost my whole train of thought, guys. I just like did a hard reset right there. But when I worked at NOAA, I would try to push these playbooks to configure my servers, and I had 1 hour to go from bare metal to running systems, right? So what ended up happening was I inverted the playbooks. The playbooks wouldn't work with the normal push magic. I had multiple servers. The main server that I was using had 2 terabytes of RAM in it, and it could not handle pushing to even 500 nodes, and we had 2,600 nodes in each cluster. And I had to be able to stand a cluster up in under a minute, or under an hour. So my portion of it had to be under like 20 minutes, my server portion of it. So I inverted it. All the nodes as they came up, they pull their own Ansible and they configure themselves. There's no push, it's all localhost. And I designed that, right? So all 2,600 nodes came up, and I remember when we did it, when we actually did the test for NOAA, because we had to verify, like we could power it all down, bring it up in under an hour. I remember that they were like, we were going through, and this guy, Dan Reisman, had to turn on all this other stuff, and then it was me, and it was my portion, and it took us 5 minutes to bring up all the servers. And they're like, all the servers are up? And I'm like, all the servers are up. And they're like, there's no one-offs. And I'm like, well, like, and aside from like maybe some note annotations of like a bad hardware or a bad DIM or so, you know, those kind of things happen when you turn off and turn on 2,600 servers. But aside from those kind of things, no, our environment was up. And I remember we were hoping to be to that point by 20 minutes. But when we did this live, and I had extensively tested this, when we did it live, we were at like 7 minutes. We were at like 7 minutes into the hour, and I had all our servers up. And they were like, we did not expect anything like that from these guys. And I'm like, well, that's why they brought me back. Yeah. That's when they brought me back to the, because now I'm back on that team, actually, even though it's all operationalized now. It's not build anymore. I was there for all the build stuff, all the stuff that's running in the data centers, both in Phoenix and in Manassas. Which I can say because they've declassified that. Like, it was never classified, but they've done published reports on it and stuff like that, so I can say where that is. All right. So anyway, so real quick, the servers now know that. Have you guys ever seen? And I don't have a good example of this from like a movie or a show, but like, let's say your kid was allergic to peanuts, and you absolutely needed to make sure that teacher saw it, and like. I don't know where I first saw it or if I heard it. I know it never happened to me because my mom didn't pin shit on me. But like people would like pin notes to their kids. Have you guys ever seen this? Like they'll pin a note to their kid so their kid doesn't forget. And then the teacher sees the kid come in with the note pinned on him, and they pull it off and they go, "Oh, this is like whatever." You know, I don't know. I don't know. My mom never did that to me, but I've seen that or heard that, or anecdotally I know that that's true. Well, what if the best way to talk to like the teacher for the parents was to do that? So every node, as they come into and drop into the top of our little Plinko machine, they have a little note on themselves of what they know about themselves. This is little Timmy's backpack. He only likes fruit roll-ups. He doesn't like pudding. I don't care what the context is. The point is the server is bringing this to the table. Why is that important? Because it doesn't matter how you drop those servers. It doesn't matter how many servers come out of that gate to attack me that night for patching. I can know these things about them because they have. It's almost like if you're ever playing one of those games and the monster's got the vulnerabilities on them. And then you're like, oh, shit, hit him with an ice, hit him with some fire. Like, you know what their vulnerabilities are. That's the same kind of thing here. And this is all now coming with that server when we do like a setup, right? So when we do setup or gather facts, this is now down in a path on Ansible called Ansible_local, and these are facts that the server knows about itself. So then very quickly you might go, well, can't you group by those facts? Yes, you can. And then later on in your playbook, can't you stop execution against all and just go against database servers and patch group? Yes, you can. Oh, you already know this shit better than I do, because I'm just the guy who makes sure that these are there, and I pull this. I pull these and deploy these. I don't do it that night like you guys are doing here in this example, but I do that well beforehand. And I constantly kind of, I don't like the term grooming, but it's like I constantly, I don't know, I guess you would say like flock your sheep or whatever. What's that called? Where you take your, I don't know, protect your sheep, whatever it would be. Like I constantly am making sure that my systems are ready so that when they come in for patching, they're ready to go. I can send them down any number of paths down that Plinko machine that I want. Is that kind of, I hope that's clear because I'm kind of beating that to death, but I think that deserves to get attacked a few times and bonked on because you will go, oh shoot, that's what that freaking guy was talking about. That's that thing that he said was hard. It's not hard if you have the servers bring their information with them, right? It's not as hard. There's everything's work, right? But I mean, there's things that'll make it easier. So anyway, so we look here and we see what is going on in this 04 enterprise patching. And here's roles, and roles get inherited in order. There's actually an interesting order of operations. It doesn't matter what you do in Ansible. Doesn't matter what order you put tasks in. I used to, when I first started this, I thought, oh, tasks are up front, so tasks get done first, and then roles, and then pre-tasks. People have pre-tasks down here at the bottom. No. The order of execution for Ansible, at least for these things, is pre-tasks will happen before roles, and then tasks will always happen after roles in a playbook. That's the order. That's the order they've chosen. That's the way that happens. Does not matter the order it is in this actual playbook here. It will get ordered. This is just a YAML config, guys. This whole thing gets slurped in. Doesn't run top down like an execution. So if you ever need to see that, right? Pre-tasks Ansible, yeah, pre-tasks, sure. Ansible pre-tasks are first. That's pre_tasks. They'll go first, and then roles, and then tasks. This is actually in proper order, by the way, right there, right? But it doesn't. Again, I don't care the order you do it. That is the order it's going to execute. Pre-tasks first, roles, tasks, and I think they probably say that in here too. But all right. So anyway, so we have, in this case, we only have roles, so everything I just talked about isn't real. And we've got a pre-check. Pre-check happens to everybody because there's no condition set on them. Fact push happens to everybody. There's no condition set on them. Patching happens to everybody. There's no condition set on them. But this role right here, reboot, this is only going to happen when Ansible_local.patching, that's the one that we pushed over there, .rebooting is equal to true. So what if there was a way to look at that? What if there was a way to say, well, what is that, right? Well, right here. So rebooting false and rebooting false. So I know on this little trip, if I put these two servers in there, none of these servers are going to inherit this role. This role is not going. It's going to be Plinkoed out this way, and it's not going to go the way of this. Server validation is going to happen no matter what, and app validation is going to happen no matter what. And the report, when report is true, report has to evaluate to true. However, the default for this is false, so report is not going to happen unless you set report to true, and the default value of report is false. That's what this filter means here. There's an interesting thing here to note. The reason I piped to default false is for a very specific reason. Because if you leave out report as a variable and then you get to this part of the playbook, it'll just crap all over the place and be like, there's no variable for report. You didn't give me report. And I'm like, well, I didn't want a report, so I didn't do report. And they're like, no. Once you add a variable, and this is true of I think many programming languages too, once you add a variable, you have to use it. You have to do something with it. Well, or when you test the condition of it, and you didn't set it, you're going to have a problem because that's what you're doing. You're testing its value. So right here, even if you didn't give me report in, I'm going to set report by default in the play to false. Does that make sense? So if it's empty here, instead of crapping all over itself and failing, it's gonna send. It's not gonna send the report because I set it to false. All right. And then sorry, here's the rest of it where it says when report equals true, but again set to default false. So it's like it's like a logic gate where I can never fail because I will just turn false and then I just won't do anything. But I won't fail the play. Because again, the playbook will just turn all red and crap all over the place. And then you'll be like, my patching's not working. And then trust me, when patching's not working and it's like 11 at night and you're looking at like till 4 to 5 in the morning, the nightmares, guys, the freaking nightmares. But I can tell you some really funny things that have happened on patching calls late at night because I forget that I'm on mute. And by the way, I am like a hardcore like check mute over and over again. But sometimes I've left myself off of mute. And I remember the one scene. I'll tell you guys the one. I think this one's funny. I was patching late at night one night. I remember I was at my old house, so this would have been probably 2017, 2018, and I was running patching. I had all my guys with me, and then there was a bridge call with like 20 other teams because we were validating apps, and teams want to validate quick so they can get out of there. Guys, I was watching the last scene. I was watching the last scene of like it was season 2 of Dexter, last episode, last scene. And you say, what the heck is that? How do you remember? Well, I remember this. It might not have been the last scene of the whole show, but it was at the end. And if you guys remember in Dexter, he got into it with this. He went to Narcotics Anonymous because like he was killing people. But if you guys don't know that about Dexter, I hope I didn't just spoil that. Dexter was killing people. So then to get away from it, he went to Narcotics Anonymous and like basically he like acted like he was on drugs. And his sponsor chick, this girl, he started sleeping with her, and she tried to burn him to death. Right, so she locked him in this building and tried to like, well, I guess smoke inhalation would have killed him first. But anyways, she everything just crapped out. Everything broke. Hopefully I'm back, guys. Chris, how's it going, by the way? But anyways, she tried to kill him. She tried to kill poor Dexter. And the scene that I was watching with my mic off was he was sitting in the back of the ambulance and his cop sister was yelling at him for being an idiot, for messing with this girl and this and this and this. And like, they thought on the call, they were like, are you getting arrested by a woman right now? I'm like, no. I didn't realize that I was watching Dexter. Specifically the scene while his sister was yelling at him in like right after he almost got burned to death or fire or whatever. I guess you would die of smoke inhalation first. All right, let's patch this. Let's run this. Oh, this was the other thing I meant to do here. So we looked at the playbook and now we know pre-check, fact push, whatever. We go down into roles, and this is one of my favorite things about Ansible is we could have a whole directory full. And this is actually, I've seen this from other enterprises. I actually inherited this from Shasta, which Shasta doesn't exist anymore. They were that was the high performance compute of Cray, and Cray got bought by HPE back in 2019, 2020. So we were using HPE systems, but with Cray support still. And then we moved off of Shasta. But this is how Shasta did it. And we just had all of our plays in here. And then just whatever play that we're calling from one roll up, we just basically grab the ones that we want. Things you need to understand about that are loose coupling. Make sure that variables aren't being passed between these. Because if these are tightly coupled, everything has to be there every time. You can't use tags. You can't do all this other stuff. So you have to use like some, I guess like what people call like good coding practices in here. But my point is I can go look at these. Let's go look at pre-check. So CD into pre-check. And in pre-check I have just my tasks. Oh, whoops. CD tasks. And in here I have just main. And in main.yaml, what's happening here in our pre-check? Well, in our pre-check, we go and we look at the major distribution and we group by the key Ansible distribution major version. So we look at the major version and the Ansible distribution and then the major version of this of these two nodes, and we drop that in there. And you might say, Scott, how do I check that? Could you quickly check that for me? Yes, we can. This is one of the, man, this is when I talk about Ansible and I tell you guys there's a fucking cult of Ansible, this is it right here. Watch. This is one of the things. This is like how, so setup. Some of you guys know I'm about to dump 16 pages per system to the screen. It's going to be a big mess, but not if I do a filter, and the filter I want is Ansible _ distribution. If I could type there, right? And anything from there. And watch this. I can see all the variables whoops, hold on. Dash I host dash M setup servers. Setup. The heck? Oh, you guys gotta remember I'm dumb. So it's root HPC deploy host. So I'm directories down. So host didn't. What? There we go. There we go. There it is. I'm done. But real quick. So how is this going to parse out? Let's look real quick. Ansible distribution. That's going to be a variable dropped right there. Ansible distribution. So it's going to be Ubuntu. And then right next to Ubuntu is going to be 24. So it'll be Ubuntu 24 as the group. Okay? It's clear as mud, right? But my point is I can see where all that stuff comes from. Ansible's very powerful like that, where I can go check very quickly what's happening within my stuff. And then the other one is I'm going to put them in a group only in the group rebooting, only when we have the local patching rebooting set to true, which we know is not true, so none of them are going to get dropped in the rebooting group, right? All right, so we got that. Let's go up one more. And we go look at our, where was that one? 04, right? So pre-checked fact push. So fact push is going to go push. Fact push is going to go push those facts like we did. If you're in a database, or if app is in database, sorry, if database is the value of your app variable on your machine, typically being passed in by some host file or some environment file, then you're going to get this DB patching fact patched down to there, or put down there. We would know. So node 01, his app is DB, so he would be getting this path. And web in app is for control plane, so control plane will have this happening to him. These technically already happened before, but that's fine. I think we ran that play at the beginning. And my point is we could just keep going through here, and we can kind of walk in our head. So now patching, what happens in patching? So CD to roles, patching. Patch. And then tasks, right? We could walk through all this, and now you're going to get apt if you're one of these guys. You're going to get needs restart if you're one of these guys. If you're rel, we're going to hit you with DNF, and you're going to get hit with a different needs restart install. So if you were to run this here, and actually I wrote this so that you could run it up here with Ubuntu systems and it would work, or you could run it in our Rocky Labs and it would work there too. So this is going to split. Again, it's like a little Plinko machine. My servers that are Ubuntu get this treatment. My servers that are Rocky get this treatment. And it doesn't matter if there's 80 of them and 20 is the split, or 50-50, or one Ubuntu server and 499 Red Hat servers. It's still going to work here because the variables, the Plinko machine always works the same no matter what. So this is like, this isn't an Ansible course. This is a security course. But my point is, like, Ansible is tremendously powerful for... It might look like I'm doing minutia stuff. I'm actually painting with a wide brush right here. I know I got some Ubuntu. I know I got some RHEL or Rocky. I can handle those. Now, you might say, but you got some Ubuntu that's 2004, not 2204. It's going to behave a little different. I go, motherfucker. I don't want to patch those anymore. Anyways, my point is, I'm gonna work on the big part of the project, and I'll just send my my engineers, my junior engineers, at the smaller problems. I'm like Zap Brannigan. He's like, once I realized that the killbots had a kill limit, I just sent waves and waves of my men at them until they hit their kill limit and fell over and finished. And all of his guys were like, this fucking guy. Anyway, Zap Brannigan's like the worst commander ever from Futurama. Anyways, all right. I'm losing my mind. But that is pretty much that lab. The last thing we would do is just execute it. Just let it run. See what happens. Does it reboot them? We can't reboot them in this lab environment. That's why rebooting is set to no. But you'll see skipping, so decisions are being made. When a server gets skipped, the playbook that's being executed or the task is not happening on those nodes. So now we're upgrading all packages to latest on both nodes. That might take a minute or two, maybe even like 3 minutes. So we could sit here and talk about it for a little bit. But yeah, this is you know, this is the kind of stuff that you need to know for if you told me, hey Scott, I want to build out, you know, a new environment and I want to set up, you know, patching from one of the local inside servers and I want to have it completely air gapped from everything else, but I need to be able to get updates. I'd say that's fine. We can do updates. We can put new versions of the ISO out there and download and update new versions of software in our environment. That's not hard to do. But we just have to be like I tell you guys with a lot of this stuff, you just have to see it work once and you're like, this is it? This is the stuff they pay people for? To just fucking be able to set this stuff up? That's it? That's it. That's it. You just had to see it once. Once you see it, you go run off, have a good career with it. But this stuff is and I'm not to say that this isn't something you have to spend some time with. It's just you can do it, right? Like you can do this stuff. You can figure it out and build it and learn it. All right, that's going to run. That's going to patch for a little while. We'll call that lab good, and then we'll go to lab 6. So lab 6 is going to be monitoring. Oh man, so this is on the plus side. I don't have to test these labs because they're not local, so I know that these labs are all good. But we'll still walk through them. I'll still show you guys kind of what it's like to do some monitoring and parsing of logs and stuff. And actually, I think I popped this one up. So. That's week 6, week 7. Did I pull up week 5? Hold on. Week 4. We definitely had week 4 from earlier. We had 1. This was week 4. We talked about week 4 earlier today. Let me see if I pulled up. I don't know if I pulled up week 5. Nope. Nope. It's week 6, 7, 10. I have week 10. Week 6, I'll show you this one a little bit here in a second. As soon as that one's done. But yeah, week 5, I don't think I pulled that one up, but it's really just talks about patching. I actually do have a couple of things I really like in that slide, so I'm going to pull that deck up. While this is running, I might as well show you guys 5 real quick. Here's week 5. All right, let's go look at week 5 real quick. While that's patching, right? We're not doing this talk right now technically, right? Not exactly, but we can kind of do the talk a little bit while that's running. So the questions here, the overview, oh, so here it's over there, done. Why is the control important for security engineering? Why does it matter that we control the repos in our environment? Well, one, for stability, right? Like I said earlier, if your devs can do whatever the hell they want, you're probably going to have problems. It's probably not going to be a good night. And I'm not trying to shit on devs. I'm just saying devs have other priorities in the environment than keeping servers up. That's not like what they do. That's not what they kind of have a specialty for. That's not, you know, what they were hired for. You're hired to keep the servers working. So sometimes because of that, you have to be a little bit of a, frankly, an asshole about permissions. I can't give everybody permissions. What does it mean to have fit for use and fit for warranty? Fit for use means it checks all the boxes, does all the things. Fit for warranty is it does all those things as often as we need it to. These come from ITIL. They are ITIL type definitions, but they've been around engineering way longer than ITIL, so that's fine. Why do we create a repo locally? Well, maybe I want to just test the install of something on my local machine. I don't want to share it with anybody. How do we create a repo locally? Well, we went and did that inside of our Etsy yum.repos.d. Even though it's DNF, it's still Etsy yum.repos.d for our repos. And we put the repo paths in there, and we use the file : / / remember there are 3 slashes, and then the path that we needed, and that was fine. How do we share a repo over the network? Well, we got to get Apache up. Then we got to share out Apache paths. And then we have to, and once we've shared out those, like that mount as repos or whatever, then we have to configure our repos in that same Etsy yum.repos.d, and then we connect into it over HTTP that time. There's other ways to do it. You can do patching over TFTP. I actually have that in here. I don't show you guys how to do it, but it's in here. And then I said, how does enterprise patching differ from one-off? Well, one-off, you just take your phone and hit update, and that's it. Hopefully it doesn't brick itself. But enterprise patching is, man, if you got 1,000 servers, I'm telling you right now, you pretty much have 1,000 different configs. Now, that's going to be different in some companies. In some companies, it's like an EC2 instance, and I'd be like, why are you even patching it? Why don't you just patch the image and kick it out, right? Golden image patching is a totally different thing, super valid. But in this case, for enterprise patching, assuming fat, what we call thick client servers, thick or fat provision servers as opposed to thin provision servers, or stateful instead of stateless, as we often call them. Enterprise patching differs in that they're all going to be different. Different tasks are going to be done to them. Different things are going to be added. Oh, the wife's getting ready to take off. All right, from Cheyenne, Wyoming. She'll be home in a few hours. Okay, and then I said, what is life cycle in engineering and how does it relate to patching? Well, we bring up servers. There's a build part of a cycle. Then there's like a support part of a life cycle for servers, and that's where patching kind of falls in. And then there's the decommission of servers where we get rid of them, and that hopefully doesn't come up in patching. But those tend to be the type of servers that I was saying, like those 17 that were dead at the beginning of patching that didn't come back up. That tends to be the reason we were decommissioning them or something like that. They were over in a pile and nobody had removed them from CMDB yet, right? Our configuration management database. All right, so anyways, that's our overview. Repositories, I talked about ISOs or RPMs are in there. And then we can locally host them or host them over the network, which you guys saw me do. And this is kind of what a repo looks like, right? So you've got DNF, Yum, Package Manager. I really like this. I think, was it Gemini? One of the early, this was a few months ago when I built this, but one of them built this for me, and I was like, that's a pretty cool little map. I'm gonna use that for my presentation. I was just throwing ideas in there, and it threw it up. But Etsy yum.repos.d, I mean, it built this ASCII art for me, which I thought was kind of cool. Red Hat.repo, managed by like a subscription manager if you pay for it. EPEL repo is your extra packages for enterprise Linux. That's what EPEL means. It also means they're not supported, so you need to think about that. Or they're not explicitly supported by the company that gives you, anything in extra packages for enterprise Linux that you're putting in the enterprise. You need to remember, if you have a support model, you may be voiding certain things. Well, you might not get support on certain things if the trail leads down to that being the problem. So you don't want to shoot yourself in the foot with that, especially if you're paying a lot of money. Then we come over here, maybe my internal repo. So we set up our own Rocky.repo, and then we defined our own base URLs and mirror lists, HTTP, HTTPS, FTP, and just regular close local files. So all of those things are there. You've got a GPG key path that is going to be where the trusted keys that signed the original packages are, and they are going to be the same between you and the vendor. You've downloaded those as you originally bought the software or got the software off the internet, right? And there's the Red Hat or the EPEL one. There's different ones like that. And then DNF Package Manager is going to read that whole situation, and it's going to go download metadata. Metadata is data about data, and also the packages into Varcache DNF. I've actually had this before where with CIS, this is actually another one of those fucking nightmare situations that you cause yourself, but you have to deal with it. VAR has to be on its own partition for CIS benchmarks. Well, we're never going to put anything in VAR, so we make VAR 5 gigs. This is actually what happened with us. This shot us in the foot for years at AAA. Varcache DNF, or Yum at the time, was too small sometimes to patch. So we'd have to go clean up other shit out of Varcache to make it big enough. Or we'd have to, it's a partition, guys. There's 2 ways to grow it. If it's LVM, add another disk next to it and then expand over it. If it's not, for some of these, we had to go in and do parted on them. So we had to take the servers down, even the VMs. Yes, hundreds of servers. We had to do parted on them to make them 10 gigs or 15 gigs instead of the 5 gigs that partition already was. So that's mounting a different disk and then expanding the file system ourselves. Fucking nightmare. Absolute nightmare. Hundreds of hours of engineering work to go fix something that was just somebody's decision that nobody thought that we'd ever need VAR to be bigger than 5 gigs. Oh, just a kick in the nuts every time it came around. This was a kick in the nuts. Just an annoyance. And you say, oh, why don't you just fix it all at once? Guys, we're talking hours and hours of painstakingly taking down servers, getting downtime, taking servers out of rotation. A nightmare. All right, anyways, patching in the enterprise. Again, it differs from just patching your desktop. There's incomplete inventories. It'll limit your capability. So if CMDB doesn't have all the servers, problem. If it has too many servers, problem. Problem. There's just problems. Like, this thing is rife with problems. If it's against multiple machines in any number of unknown states, oh, those servers. They're going to have packages that people have installed on them. Maybe they had pseudo rights to do certain things. You're going to have RPM databases that are unreadable, and DNF can't work if the RPM database isn't readable, because it can't compare what's needed versus, so it can't read the required packages to make sure dependencies are there and then download more dependencies. It can't do any of that. So that'll just break everywhere. So that's actually one of my pre-checks always, is I check my RPM database and I rebuild it if I need to. It's part of my pre-checks, because that saves you trouble at the end of the night. You know, you want to get as many of these servers through that Plinko machine as possible. System must point to a controlled repo, otherwise they're just pulling anything. They're just pulling shit out of the ether and pulling latest packages out of the web, and that's like one of the most, that's like a nightmare. That should keep you up at night if stuff's just getting pulled out of the internet, not stuff that's being tracked. Same reason why we turn off, if you've ever been a dev and you're like, why won't they let me just download this Docker image I need to the company? Oh god, such a vulnerability, right? It's like you're just bringing in a ship of like plague rats, and you're like, what's wrong with these plague rats? These plague rats are nice. And it's like, you guys ever seen that little rat and he's holding up the little present and he goes, oh, I brought presents, and it's like he opens it up and it says it's the plague, and you're like, fucking rats. There's a little meme that's kind of like that little meme template. And then patches introduce new variables and instability, so you must apply them to lower environments before production or customer-facing environment. That's always true. You got to roll your patches through your environments. How does that look? It kind of looks like this. Vendor patches get synced down to some local central repo that you have, right? And then you do them to a dev environment, you do some testing, you do them to your testing and QA environment, and you guys, between dev and prod, you can have 100 different environments. I don't care. The process is going to be sync something down at the beginning of the month, start moving it through dev, start moving it through testing and QA, and it says testing, validation, no issues found, fix, troubleshoot, no. If no, don't proceed, or if there's no problems, proceed. But here's the thing. Dev and testing QA have one thing, they don't have the one thing that prod will always have, which is systems under load. You cannot test a system under load outside of prod. And you say, well, I can generate some load. Yeah, but you can't do what users do. I got a lot of user scripts. I know exactly how users behave. Users will always outbehave your scripts. I'm just telling you right now, like, users are always going to behave differently. So you can do the best you can, but you're never going to be perfect on this. So just remember that. And then you get down here, then we go to like a testing, validation, maybe even a staging environment if we have it. We get a change management approval. I argue change management approval would have already been happening, but sure. No issues found, proceed. And then we do our general production patching. Apply patches carefully. I think that's funny, that word carefully. I need to pull that out of because I have this in ASCII. I need to pull it carefully out. Verification and monitoring, make sure everybody's got to app validate. I validate servers and I validate apps when I'm done. That's all part of my Ansible playbooks. But that being said, I can't guarantee that this isn't gonna. I can't guarantee that everything's up, right? They got to test it. Post-patch reporting, do you do a compliance audit? And then it says rollback plan if severe issues. Man, your rollback plan is going to be a nightmare if you ever have to kick that off after, like, you do 10 hours of patching and then something happens and you got to roll all that back. That's going to be bad. You need your testing good enough that if a rollback does occur, it's only in 1 or 2 environments. I will roll back 30 servers gladly over the whole environment, right? And I would prefer that. And then patch cycle complete, get ready to patch tomorrow. If you guys have never seen hold on. I have a meme I made for this. Hold on. I made a meme years ago that I think is funny. I might be the only one that finds this funny, but it comes from Rick and Morty. When she's like, we celebrate the finish of the hunt tonight with a hunt, for tomorrow we hunt. And see if I can find this. I don't have a good keyword for it. Too much patching talk. I did this to myself. That's one of our guys. Michael Pessa. Alright, I'm only going to look for a little bit. If I can't find it here in the next few, then we'll be done. Those are different. 10. Ah, here it is. Patching system for 24 hours straight. Tonight we celebrate with patching. For tomorrow we patch. And here's our Linux team. Fucking killing all the vulnerabilities. The security auditors are just covered with blood. Anybody remember that episode of Rick and Morty? That was funny. That was when Jerry was trying to date the alien to make the mom jealous. But all she wanted to do was hunt. So anyways, yeah, patching systems for 24 straight hours. Tonight we celebrate with patching. For tomorrow we patch. Yeah. Hilarious. Hilarious to me, maybe not to everybody else. And then what do we do this stuff for? All right, so we're all done with that one. That one finished patching. We come here and we see the report. We see all the pieces of it. Did we actually... We didn't do a report. I didn't add a report portion to this, but we could patch, do all that, and then send it up into our Discord as well, which is kind of one of the last things. SOC Hokage said, did you create this lab environment? I'm studying for EX294 now. Great content. No, Hokage, I did not create this. This is Killer Coda. But I did create the labs in Killer Coda. So all the Ansible ones... let me go here. I'll show you. I'll give you a link to them. All my Ansible ones I did write with the professional Linux users group, but I did not build the actual environment. So the environment here is Killer Coda, which is free on the web. They don't charge you guys nothing. They're a great tool. And then these are all my Ansible labs here. We were specifically down in this one for the security engineering, which was Ansible enterprise patching. The security engineering stuff, by the way, is all free as well. So everything you see over here from the books that the guys made, these are the Linux admin course and the Linux security engineering course. They're free. They're just out there on the web. And if you're like, where do you find them on the Discord? If you go to our Discord and you go to beginner start here, there's a nice little section. And it's got the books free. And it's got the Linux sysadmin course up on YouTube and the security engineering course up on YouTube. I'm going to run the security engineering course again next month. We're going to start again. It's a 10-week course. It's free. All you got to do is go up in Discord and hop in there. All right. Also, figure out what people are messaging me about here later. So again, today we're really just doing labs, right? We're not even working through the whole course. If I was talking for the whole course, I'd be talking all day, but we're really just making sure the labs are still aligned with the rebuilt home environment. And this is a professional Linux users group lab environment that you guys can get into. So in keeping with the lab for this week, there are 4 major architectures for collecting and storing logs. Okay. Within these architectures exist many mutations of the archetype and problems to address and scale. Okay, so this comes from my worksheet I made you guys do. The lab touches 3 of the 4 archetypes. So 1 is just rsyslog, forwarding and collecting. So there's a basic rsyslog. Node 01 sends its logs over UDP to control plane. Control plane rsyslog turns on to catch, and you just start launching logs into it. And you can send logs from all over the environment into one centralized place. Pretty straightforward, and the lab walks you through it, right? Julius Caesar said the security course starts on the beginning of September. Yeah, if you want to do this, if you want to do the security course, you go here in Discord. Top left if you're on a PC. It's on the top right if you're in a mobile. And then you just go down here and you find the security engineering course, and you just say you're interested, and it'll alert you when we're doing it. Now it's 3 o'clock my time, but for you guys it'll be whatever your time is around the globe. I know everybody's everywhere. So for me it's 3 p.m. on a Saturday. So hopefully that's not too late for some of you guys, and hopefully it's not too early for some of you. But the security engineering course, real quick. The only thing that we require to get the certificate from us, if you're going to do the course with us, you do not have to show up. There's no attendance. You do not have to do the labs. You could do the labs by yourself, but you don't have to do them with us. But the one thing you do have to do is come in here and do the discussions as we're doing the security. See, the admin ones are the only ones left. We'll post security course discussions in here, and you guys will have to respond to them within that week, right? It's like a requirement. It's almost like I'm a college professor or something. I've been doing this a long time, and there's something about just working through things and talking through it with a group. You actually have to do one post and one response to somebody. Something about that just helps you to solidify information in your head, right? It helps you to remember things. I will be Central Mountain Time. What is my time? I'm in Phoenix, so I'm Pacific right now. But if you look this up in your Discord, it'll show you the exact time. So Mountain, I think, will be 1 hour ahead of me. So I think that'll be 4 Mountain, if I had to guess. Yeah, I think that'll be 4. Although halfway through it, it's going to change because, there's the time zone change. That Phoenix does not apply the time zone change. So I'll slide back and be on the exact same time with Mountain Standard again. So, anyway, so then there's that. So we do that one. And then the next one is we forward in. So the first one, is rsyslog forwarding and collection. Then we have agents forward to a centralized platform, which in this case is Promtail to Loki. And we also do some stuff with like Python, and you can mess with that a little bit. And then we do the last one, which is message queues with log aggregation and propagation with Apache Kafka. So we send from one node into Kafka, another node pulls it out and throws it up into Loki. This is a extended, and you might say, why would you have that extra hop? Maybe control plane is in a controlled environment and he doesn't have the ability to get out. So we send him into Kafka. Kafka is a message bus that is allowed out or is allowed to go across multiple networks, and then we can pull that out and feed it into our enterprise SIEM or whatever our solution is for, monitoring or whatever over there. Kafka to, and then I did there's a cloud native one that you could go and look up as well if you wanted to. Okay, so I think this one's pretty good. I don't actually have to do lab 6, but I will show you guys some fun stuff from the presentation. So you guys that are watching this and you're like, oh, this guy just does these labs or whatever. No, when we do the presentations, there's a full. Where's week 6 at? There's a full presentation that I do with this as well. I'm not doing it right now, but what is a log? How is a log an immutable record of what occurred? How do we use logs? What are their common elements? What is their structure? How do we store them? And then what does it mean to have rotation? And then how do we parse and look at information in logs, right? So then we get in here, what are the logs? We troubleshoot with them. We do security auditing. We might use them to checkpoint performance of apps or debugging applications. So we can use them for all types of reasons. There's all kinds of things that we can do with logs, right? Again, we're not doing the exact course, but this is recorded, right? This is up on YouTube if anybody needs it. That's what I was showing in the Discord. That's all there. Log elements, they follow a format. There's always, whether you're doing the BSD, which is RFC 3164, or the newer RFC 5424, your logs must be timestamped. And we tend to use ISO 8601, which is a very common timestamp format. Logs must be categorized by severity. It allows us to properly route them to different locations and know what their hierarchy is. And then common in all of these systems are debug, info, notice, warn, error, crit, alert, and emergency. And there's the lowest to the highest level of alerting right there, which, by the way, allows for proper routing of them. So log elements. So this is RFC 3164 by BSD, and this is the older, more basic format, and it looks something like this. The year is intentionally left off. The year is not used in logging. It has the date, the time. It has the host and the process with the process ID. So this is the process name, process ID, and then some short usable message. We hope it's a usable message. But it is immutable. Once it is written, it's like law. You don't change it. Well, you don't change it willy-nilly, right? This is the accepted format. It's always going to be there. Whatever's written here and stamped, if you want to take that and parse that down and say password for user 1 was sent in at this time, and you want to make that a different message, you can do that, but you do not change the original log. The log is immutable, right? It just doesn't change. We don't change it. IETF 5424. This is an example output here. 23. This one has the date, and then it's 1026, and it's this is also a longer time standard. The same server, SSH, the process and the process ID, and then an accepted password for user, whatever, right? This is actually, again, using the ISO 8601 format. The other one does not use the ISO 8601 format. This one does have the ISO 8601 format. So this is what I tell you guys, if you do API work ever, you're going to see this your whole career. It's going to be one of the most parsed down and chewed up timestamps that you're going to see. This one right here. So might as well get used to it a little bit, right? Systemd journal isn't really designed to be sent off. This is more of like a local troubleshooting, and this is not in a readable format by default. It's stored in binary format, and that's for it's more compressible that way, right? It's easier to store. You don't directly see text-based messaging if you look at it. In fact, you can't even read it. But these are the things that are shown in there, and they allow you to see what's going on with the system as it tries to start and restart programs, right? That's what journald or journal and journal CTL try to show you. What's going on with applications that are trying to start, what's going on with anything really that wants to write to the journal. Okay. Capturing logs.
How are we able to offer the Willow Creek bed for just $195 at Living Spaces?
No. That's an ad.
How do you attract a man?
How do you attract a log?
What I mean is, suppose you set your heart on somebody.
On a log.
What would you do to get him?
Grab him and take him.
You grab him
You'd grab the log.
and take him.
You grab the log and you take it.
Like that.
I love it. All right, so log storage and rotation. Don't worry, that's coming back around again with more. Log rotation is an essential process. We need to be able to make sure processes don't fill up and don't have. That's hilarious to me, by the way, guys. That might not be hilarious to all you, but it's hilarious to me. I grew up with Conan the Destroyer as well, so that's all right. We got log rotate utility. We got different utilities, but Linux has like this base one that's pretty good. Does most of the stuff that you need. It can it can rotate, it can compress, it can do all kinds of things, right? It's got all kinds of useful stuff. But understanding and properly configuring log rotation is crucial to maintaining service or system stability and manageability. So we talked about logs, what they are. We talked about the format that they're in and how we get them. And then we talk about storing them. But one of the most important things I could possibly tell you about logs, and this is crucial to like architecture of this and security, you have to get logs off of servers in real time. Because if you don't, and the server has a problem or goes down or whatever, well, one, you don't know if a server went down maliciously or just from heat or something. You don't know why it went down. But when it comes back up, that's when you get to start figuring it out. I would rather have the log and be able to start looking at it now while the team is trying to turn a server back on, or while we think about moving on off into a quarantined environment before we start it. I have the log and I can see what was happening before somebody does it. I mean, how many of these movies out there, how many terrible fucking movies are there out there where somebody's like, no, don't open that. And he's like running to stop the person because he's, deciphered the text, and they open it and they get they get an alien in the face, or they get fucking blast of the dirt, from anybody here ever seen Ghosts of Mars? Once that dirt gets into you, it just fucks your world up. Basically like this virus on Mars that kills everybody. That's a pretty good one too if you've never seen Ghosts of Mars. That's a surprisingly good John Carpenter film. Anyways, we want to send off logs in real time. That's really all there is to that. So rsyslog common, logging architecture with agents and a centralized platform. You got Elk Stack. Typically, like Logstash is collecting those logs. Splunk, Graylog, Loki. There's a bunch of different ways to send data off of servers in real time that are so that's non-native, but it's agents to a centralized platform, as opposed to like rsyslog, which is built into all Linux boxes, and you can just point them all at one, and they'll just shoot all the logs over there. You can use message queues. That's very common nowadays, guys. Like event-driven, event bus, event bridge inside of the cloud, managed services for Kafka. Those are AWS services, event bridge and managed services for Kafka. Kafka just down in your environment. Message queues are hugely popular for, just how information communicates, right? You can do all kinds of stuff with that. And then there's cloud native logging services. You can send VPC flow logs and all these other things. There's all kinds of logging that you can do, and then you can parse it up and you can look at that data. But sending off logs off the server is very critical, and these are the 4 kind of common architectures nowadays that you're going to run into. You could probably find some very niche ones that are different, but this is a pretty big bucket. Send it off with our syslog, some kind of data collection. Send it off with an agent. Send it off with a message queue and do like event-driven type programming, and then cloud native stuff, whatever your cloud native provider is, right? Choosing the right architecture, you got to think about scale, reliability, real-time needs, your budget. Do you want to spend a bunch of money on something that's literally... We used to joke around about this in government systems. You guys have all heard of Worm, right? Worm type storage. Worm is what write once, read many. Worm type stuff is like weather. We read stuff out of the weather data and we never change the original read. It's immutable. But we read it many. So write once, read many is very common. But we used to have this saying in some government systems, which was WARN. Write once, read never. And if you think about that, it's kind of silly, but why the fuck would you write something if you were never going to read it? Why take a note if you're never going to read the note? But sometimes we get stuck with that in government, and we do a lot of writing data and then spend a lot of money. What's your expertise? You know, are we going to all have to learn Elk Stack to manage Elk? I've been on projects where people are like, that's what you're doing, and then they just won't do it. They'll go do either leave the team or leave the company because they're not going to work with certain technologies. You guys know that there really are people. You might not believe that when you're like, well, it's a bad economy right now, or it's a bad job market. There's some guys that don't care. Some guys have been engineering so long they don't even have to do it anymore. You know, or they come from long lines of engineers and they don't need to do it. They can go anywhere and do whatever. But I know people like that, and they just won't work with certain technologies. And you're like, all right, well, fuck it. You see that a lot with old Unix engineers. They did not like working on Linux. Compliance requirements and existing infrastructure. So anyways, there's a bunch of reasons to choose any of these architectures. So in our labs, so this was, but once I have the log, what do I do with it? Well, that's simple. You just join. So in that scene, I'm not going to spoil that scene. Go watch it if you want to watch it. It's a pretty funny show. And that's Conan the Destroyer, by the way, not Conan the Barbarian. That one's okay, but Conan the Destroyer was absolutely a masterpiece. There's a guy that tells him, give us the girl or we'll take her. And Conan goes, enough talk. And he flips this knife over and just throws it in the guy's gut and kills him. And you're just like, dude, you were talking all that shit. And Conan just threw a knife into your fucking stomach. All right, I'm done swearing. But parsing logs with text tools. You got to remember when you're parsing systems, right, or when you're looking at logs in general, right, you can scroll way too many logs, way too fast to read, and that's not super great, right? There's who knows what's going on. I see a bunch of logins. This is actually all the logins from my Ansible playbook, and I can't really read that too well. So then I start using tools in a way that maybe makes sense to me to try to like parse this down. I might do something like this. I might cat that out, and then I might know that maybe I grep. Let's do this. Let's this will be a fun one. We'll go like this. We'll grep, or we'll awk with a field delimiter of colon. Which, by the way, where would a field delimiter of colon fall? Right here, right? So we're kind of doing something sneaky where we're grabbing all this over here on the left. Because we did colon, and if we grab the first field, and then we sort those, they're already sorted, and then we do a unique -C, watch this. I just looked through that log and counted up for August 16th, which, by the way, is the only log that's in there. The 17th, 18th, 19th, 20th, 21st, 22nd, 23rd, and 0 hour of the 17th now, because we're in the 17th. And now, like, the logs are only open as long as the server's been up. So this server's only been up for 7 hours. Is that right? Yeah, 7 hours since I rebooted it. I just counted up how many events were in each of those right there. That's what that did. So if I were to look for, if we were to just look at that, and the far left number is the number of times that something happened, and I said, hey, where was the most eventful hour of this poor server's 7-hour life? Because by the way, the server's only existed as long as he's been up, and when he goes down, he's a stateless node. So when he comes back up, he's going to be like one of those Urukai getting pulled out. What were they called, Urukai? Like they were born and they were only like 2 days old, but they were already getting killed by Boromir. But they come out like as adults. Anyways, my point is this server doesn't have any knowledge, but the most eventful time of this poor server's 7-year life is that first hour it existed. 1,207 things happened in the logs during that time. So, maybe if and also I can parse that down and look for anomalies. I can parse that down and look for, we do errors instead of this. I was just going simply by timestamp, and I just used a simple little awk to cut it up. So my point is to tell you that there's a lot of different tools, and you can start simple. Begin with basic commands like grep to filter relevant lines, add more complex tools like awk or sed for more specific manipulation of the files. I don't really know anything else except some basic pattern that there was a lot of events happening at this time. Maybe this was when we were building the servers and we were doing some kind of updates to them across the board. So I don't know. I don't know why that has so many lines compared to these other ones, but I know that that's a high outlier, right? We can use regular expressions with grep and sed and start to get pattern matching and looking for things happening. Then we can iterate and refine our tools down. So maybe we know that certain processes and certain things look a certain way. So we do that. And then we save off useful commands. Like if this command was useful to me, I go save it, store it in my little notebook or wherever I store commands. I tend to keep things in, I got a bunch of different Notepad programs, but Notepad++ is one of my favorites. So I just find myself throwing stuff in there all the time, right? So anyways, we weren't really doing this presentation right now. This presentation's up on YouTube. But we were going through and looking at the different stuff that you can do with logs, right? And then the labs are over here. The labs are all free. They're up in the Discord, how to get to the labs, right? All right, so let's go hop over to 7. Lab 7 is our next one. And we're skipping over, again, the lessons each, because I'm just really playing with the labs and making sure the labs are good. This lab is going to be monitoring jails with fail to ban. So we use fail to ban on the box, and then we send that into some location, and it looks like we sent it over to Loki, Promtail, and Grafana to present logs on the dashboard. Okay. So fail to ban is going to have failing users out that try to connect into us, and then we're going to be able to present those logs on the dashboard. That's probably good. Okay. That's also in Killer Coda, so I know that one still works. Then we do some telemetry data, and we show the metrics on the dashboard as things go. And then I believe on this one, we actually alerted this out to Discord as well. Can you trigger that alert out to Discord? And when we are doing the log, and we'll do this next when we actually run the course again, if you go to Sandbox, I send stuff up into Sandbox all the time, but other guy, Zorgel, one of our guys, was sending stuff up the other day, and he didn't even realize that he was sending it, so I thought that was kind of funny. But our Sandbox channel has a webhook that you can use if you're part of the course. As long as it doesn't get abused, I leave it open, but when it gets abused, I blow it away, and then we make a new one for the next course. But up here, these are all my monitoring ones, right? Like, how's our systems doing? But I want to show you guys. So this was, who is this? This was Versed Acorn. So one of our guys was triggering high alerts in Grafana, and then as it cleared. So it was as it was firing, and then I believe as it also cleared. So firing and firing. Sometimes you see when they clear as well. Sometimes you don't. But the point is, oh, here's resolved. So somebody had a resolved one. This was me on stream a while back. And then this one was also me firing on stream as well. So I was triggering an alert with a jail of a user. This goes back to that jailing stuff. And actually then failed to ban, jailed the user, and didn't allow him to connect. And then when it resolved and went away, Grafana also sent an alert for it to disconnect or whatever. Now, the source here is localhost 3000. That's not exactly going to work for us because that's not configured correctly, and it's connected to a lab that doesn't exist anymore. But in your own environment, you could fix that source to be the actual path to your actual metrics dashboard or whatever you want to go fix or whatever. So, all right. So we don't have to do these ones as well, but that's there. Let's go look at Unit 8 labs. Unit 8 labs were configuration, drift, and remediation. All right, we'll do this one, but we had some Stig Viewer stuff. So Stig Viewer is the secure technical implementation guide, and we looked into change management and did a little bit with that. And then we went and did a configuration with drift and aids. So we'll do this one real quick, but I'm going to take a break real quick because I've been talking for 2 hours. So let's turn that off, and I will just put up for now. Actually, I'm going to move that down. So there, that's better. Now it's not over the chat. And I'll put my little hourglass up. And you guys are welcome to hang out for as long as you want, but we will do, let's say, quick break and stretch your legs. So go take a walk, wander around, smoke them if you got them. That's what they used to say in the military. I never smoked, but long drink of water. Sending grounds, stretch and mobility. We could all use more of that. Absolutely. Yeah, sending grounds. We had a yoga challenge at work, and I logged 0 days of yoga in like the last 60 days, so I did nothing. However, I did do a whole lot of non-voluntary yoga by doing Brazilian Jiu-Jitsu. I probably did that about 30 times in there. I just didn't record it. And that was a bunch of yoga, but it's mostly me making the other person stretch. I'm just kidding. I'm actually very, I'm very limber for a big guy because I do a lot of stretching and quite a bit of grappling. So, all right, I'll be back. We're wandering around. Take a break, guys. All right, 9 minutes. I'm back. Hayes, you do yoga every morning? Nice. That's pretty good. It's healthy. It's good practice, good strength, good limber. I got a lot of buddies that do yoga. Let's finish up these last couple labs. I'm just, again, kind of running through them and cleaning everything up, making sure it looks good. Yeah, I did a little stretching. Oh, I had a raid from Overgrown Carrot. How's it going, man? I haven't seen you stream. You know what's funny is, so I got up, I was walking around my upstairs of my house, and I was like, I went in my room and kind of just wandered around, and I looked down on my phone, and I literally said this to myself like about 5 minutes ago when I walked away. I said, "Oh, Overgrown Carrots online. I haven't seen him." I thought to myself, he hasn't been streaming in a while, and then you raided me. So sorry for missing the raid. What we're doing here, guys, is actually, this is directly cybersecurity. Overgrown Carrot is a big part of the cybersecurity community around here. And what's that one that we're on where it kind of like shows people cybersecurity related or cybersecurity? There's a name for it. I think GoPro Slow Yo runs it or something like that. But what we're doing right now for people that haven't been around is we've got a course. This is a free course. It's on security engineering in Linux. And what I've been doing pretty much all day is going through the original course. I think we're up to Unit 8 right now. Yeah, we're on Unit 8, but we can jump back to the course syllabus. This is a free course we run out of our Discord. I'm going to run it again next month. And it is about these topics, these major instructional areas of security, but with Linux as the kind of flavor of how we touch it. So it's build standards and compliance, so it's building Linux systems securely. That's what we're doing. InfoSec streams, that's exactly right, Fix It. Yep, that's how I think he and I met. And then I hadn't seen Overgrown Carrot. Fuck, man, I haven't seen his streams for a while. That can be timing and all these other things, like I'm not watching streams or I'm working or whatever, but I'm just kind of giving a little review. We're still on break. Feel free to keep on your break, guys that are doing that. We just, I give everybody a break every now and then if I'm lecturing a whole bunch. So, but anyways, we did build standards and network and security connectors. So again, building a secure Linux box from scratch. How do we do that? Like what's a way that you would in an organization say, this is how far we're going to go to get our Linux to 60 or 80 or whatever percent of like a current standard. And standards that we commonly use, this can be a flashbang, I apologize. We use like the DISA STIGs, very common. And I tend to use like Rocky or RHEL Linux, so RHEL 9. And then we, get rid of this keyword or whatever we're using here and remove all filters. And there should be 400, whoops. There should be 452 total rules in here for securing the system. And if let's say your organization's running Red Hat or Rocky Linux and they don't have any security standard, well, your first pass, your goal might just be to get like 40%. Get to 40%. Or another very common goal, let's get rid of this and let's make a new checklist. A very common goal for us is like, just knock out all the Cat 1s. Cat 1s are immediate system compromise if the vulnerability the vulnerability or problem that's being addressed isn't addressed. So all the Cat 1s, that's only 20. You just got to make sure that you are using FIPS. Well, that's a big one, but let's say that you had to put FIPS on your dev environment and run it for a month before you moved it over to prod. That's not that big a deal. This is also FIPS. This is, you can't have null OK in the password for anything that's privileged, right? So you got to make sure that that's not there. And anyways, there's a bunch of ways to automate these, and I was showing all the remediations and stuff. But that's the first week. That's the first part of that, is like getting into like a standard. And guys, there's all this noise in standards. And one of the things that I try to do in the course is not make you guys just be drones. I try to make you guys look at stuff from these areas, which are the categories. These align to the Security Plus standard right now, but I'm used to a little bit different one for my CISSP stuff. But technical, administrative, and physical are the way that I'm used to looking at these. And we look at, as we're doing each of these labs and as we walk through the lessons, we talk about, okay, so there's 452 things we can do, but we can't turn them all on because that'll be too much. That'll lock the system down too much, not usable to anybody, everything's busted. So if we're not going to do one, we need to understand what type of control it is. Is it technical preventative control? Is it a physical preventative control? Like, is it stopping people from physically accessing a server console? Like, all these things. And we put those all together into kind of like a comprehensive way that we lock down and build our servers. Also, in this one, I think I made you do like MariaDB. Then we secure the network, and we continue on with how the system interacts with the network, and we look at the kernel parameters and stuff. And then we allow users onto the system, so that's like at week 3. Bastion hosts and air gaps, and how we jail users and allow them to pass through our systems. And then we update systems and do patch cycles, so we worry about that, and that's what we just finished. And then we pretty much blew over the top of these ones pretty quick, but I was talking about logs for a little while, right before break. And now I think we're jumping up into Unit 8, which will be here, configuration, drift, and remediation, and we're going to go do those labs. And really, I'm going through the labs right now. We're not doing the full lessons, but I'm going through the labs and just making sure that everything is kind of on the up and up. The lab environment that I have for you guys to log into is good again. All right, good. Break's done. Break's officially done, but I was just kind of reviewing stuff with people. Here's the course objectives, and I always tell people course objectives, much like if I built this off of a syllabus template that I have, right? The old syllabus that I had from a college that doesn't exist anymore. And I modified it. And then course objectives, these are the things that are like my contract to you. And like Zorgel just went through the security engineering course. So Zorgel, who's around here, could tell you that this is almost like my contract to you. And I tell my college students the same thing. This is my contract to you. If you do the course with me, you will be able to, well, if you do it and you understand it, you can put these things on your resume if you have nothing else. If you're trying to get that one-page resume put together, if you're trying to get a little one-page resume and you don't have anything on it to do, this is my example resume, right? This is not real information about me, but you can dial 867-5309. That's a great number to call, but that's not the song, right? Or some phone number in a song, but you can start to buffer your resume, your one-page resume, and make it look good, something that can be usable. These are the types of things that people are looking for in the Linux engineering and Linux admin space and all those kind of things. Jenny, that's exactly right. Yeah, it's Jenny's number, right? 867-5309. So anyways, I brought all that up to say we're not really doing anything like that today. I'm just going through the labs. And that's what, if you look at even the stuff earlier today, it's just, I've just been realigning this. I rebuilt the labs the other day. All of our werewolf stuff is back up and running. So we've got a whole big werewolf environment that allows people to log in. And the logins come from the web, prolog.asuscom.com. That's a a dynamic DNS that we have. And then you can jump in, you get jailed in our Jump02 box, and then it drops you over here. For people that want to connect to that, all you got to do is jump into our Discord. And in the Prolog lab environment, you just give me a key. Public key. Don't give me your private key. Public keys, drop them in there. You guys can connect right in and use the boxes. All right? When they're done, they just wipe. They're werewolves, so they're all stateless nodes. I'm not going to go into werewolf right now, but suffice it to say I am putting together a presentation on that because I'm doing that for work, actually. So I'm doing a little brown bag at work on it. So I figure I'll do it outside of work first and then bring it into there. But all right, so we're on lab 8. So let me go down to 8 in the lab and do a little bit of Stig stuff. And then we go to one of our Killer Coda environments. So let me go find Killer Coda real quick. Maybe I threw that one away. All right, Killer Coda. Boom. Killer Coda. And we are just going to go into one of their sandboxes. So I never built this one for real. This is just in a sandbox environment. So if anybody wants to follow along with me, you would simply go right here. Very good. Yeah, 1 out of 1 Zorgels agree you guys should do the security course. So what this is going to do, this is going to drop me in an Ubuntu environment. If I know nothing else about the environment, I now at least know those variables and those things about it. And this is just plain Ubuntu, so we don't need any of their sandbox stuff. We are going to do all of our stuff over here. And we're going to install aid and watch it happen. So app-y install aid. -y takes the place of us having to say yes. It'll just install things for us. Oh, Colchis also recommends. Good. Boom. 2 out of 2. All right. We're going to hit OK. Sure. Sure. Just install. Don't care. All right. So aid is going to be installed on this little Ubuntu box. And aid is the enhanced intrusion detection environment. aid is very much what Tripwire used to be like 15 years ago. Tripwire was this project. That just reminded me of something that I have not thought about in a long time. You guys want to hear a story about an old college student that also came from that college that no longer exists? In all my years, I've only ever had one person ask me for a letter of recommendation that I've told no, and it was a college student of mine who. There was a class we did. It was actually a 400 level class on Linux security. So it was like bachelor's level stuff, right? And these students were working on their bachelor's degree. And there was every week when we did the class, it was a 12-week class. Every week that we did the class, this girl would ask me questions about getting Tripwire working, and I had told her about this whole project, which is very similar to like what we're going to be doing. And Tripwire will check some and validate that nothing's changed in your environment. And she asked me every week about this project. And at the end of the project, she turned it in, and she got a good grade. I don't know exactly what she got, but she got a respectable grade. And then this other student turned in the exact same project as her. So I went back in and I changed her project to a 0 and his to a 0, and said they were cheating, right? And it was the exact same fucking project, guys. Like not similar. It was like copy paste change name. So I get a call from her, or I get a call from the counselors. I don't remember exactly how they got a hold of me, and they're like, "Hey, this student really needs to talk to you. She wants to find out why her grade got changed to a 0." And I said, "Hey, she's cheating." So anyways, I talked to her, and come to find out, she didn't cheat. She had worked on the project, and I even asked her, I was like, "Why did you give your project to this other dude that didn't fucking do shit the whole time and was just a piece of shit?" And she goes, "I didn't. He asked me the last week of class if he could use my jump drive to get some math homework off of. He needed some math help. And he must have just taken my project and turned it in." And I'm like, "Well, that's exactly what he did." And he still got a 0. But I was like, "All right, I'm going to give you your grade back on that," because she was like legit crying. Like she was going to fail. And I felt really bad for her. But also, I kind of felt bad for like her naivete. Like you would keep everything on one drive and give it to somebody else. Like, yeah, but this dude just ripped her fucking thing and thought that like in a class of 20 students, I wasn't going to notice that he turned in the same thing. And I'm like, do you guys really think that I just like hit the button and give you like A's and B's and C's and don't even look? Like I'm at least, I was curious the whole time that we were building, because this class was just building these projects. That was like legitimately the whole class. In fact, I still have the book and the workbook for that class. I can go get them if you guys wanted. There, it's like it was like a, what was the number on that class? It was like 408, but I think it was IS, like Information System Security, ISS 408 or something was the number of that course from ITT Tech, which doesn't exist anymore. But yeah, I this fucking student stole this other student's thing. And again, like I'm not going to get into what was going on with the math class. Maybe he just like framed it like he wanted her notes and whatever. But yeah, he stole her whole thing. He just took everything off it, gave it back to her, didn't act nothing. She was wondering like a week later why her, I'm pretty sure it was an A, because she did a really good little project, had just turned to a 0. And then like I had to go clean it up in the grade book and go through admin and stuff. But he's the only person, that student had the audacity like a few months later to ask me for a letter of recommendation. And I was like, guys, I'm going to tell you guys the same thing, because people ask me for letter of recommendations in the prologue. Like I get stuff like that. I will do it, but I will never lie for somebody. And you say, what, Scott, are you some oracle of bastion of goodness? No, I just don't lie for people. I will say all the good things I can about you, and I will dance around all the bad things. But that guy never gave me a single good thing to say about him. Never once. And do you know the thing I'm going to tell you something that's going to make probably one or two of you mad. I was an infantry guy, right? I was an Army infantry guy. And like, the thing I told this guy this. I said, do you know what? You're a fucking Marine, dude. You were a Marine. Like former Marine, or you don't call them former Marines, always a Marine. I was like, dude, you do not do your service proud, man. You are a shitbag. I told that guy that. And the funny thing about it is he knew it. He didn't even want to fight me. Most guys, if you told them that, would fight you. And I was ready to. I was still in my 20s back then. I would have fought the shit out of him. But anyway, I think I was only like a blue belt at the time in Brazilian Jiu-Jitsu too. Now I'm a black belt. I'll fight anybody. But anyway, and I'm in my 40s, so I don't really want to fight anybody. But I'm just saying, like, this guy legitimately, like, just stole her fucking project, man. All right, I'm done swearing. The wife doesn't like me swearing. She's not home yet. But he was recommended. Yeah, I could. You're right. I could have said he was good at social engineering. He's always a Marine. But I'm just telling you, like, the best student to this day, the best student I ever had come through that college was this old guy. His name was Troy McCourt. He made this. I remember in the structured cabling class, he made this spreadsheet that if he had ever given it to anybody, would have just made that class's final project null and void, because literally all you had to do was put the things in. It did the whole project for you, all the runs and all the distance and stuff. It was a masterpiece. This guy was the same level. I was a senior engineer at Lockheed Martin at the time, and he was a senior engineer at Honeywell. So he was retired from the Air Force 30 years, and he was a senior over there. And he came down just to burn. He was just burning his GI Bill, guys. That's all he was doing. And you know what? He still did the best work I ever saw. By far. Like, not even, like, by far and away, and not even close. He had a 99.9 in all my classes. Just there was no fault in that guy at all. And anyways, it was funny because like he would do in classes, like I would always make students tell me the interesting thing about him, and he would always tell everybody, I have 10 grandkids. And it was funny. And he and I would go out to lunch every now or dinner every now and then because it was like a night class. You were the best C- student around, bro. Hey, I'm not gonna fault somebody for whatever their grades are. I'm just gonna fault you if you steal blatantly from another student. That poor girl, man. But anyways, all right. So aid is there. Let's do aid-v to get a little information about what aid can do in our environment. I haven't even looked at this in a while, but it's got a whole bunch of stuff that it's able to understand and know about, and that's cool. That's cool. It can tell us all about this stuff. Then we come down here and it's like, hey, here's all the hash sum attributes I know about and can do. Like I know about like MD5, SHA-1, SHA-256, SHA-512. All these other ones, I don't know what any of these are. Stringy blogs and all that kind. I don't know any of that stuff. Does lunch money count? Yeah. So my point in all this was saying that like, there's all this stuff that this can do, and then default compound groups, and there's just other information in here that it'll look at around the systems if you want. Okay. You found a fault. I would have given you 99 instead of 100. Yeah, that guy, man, his stuff was just so good. But my point in saying that he was already an engineer is he didn't need it. He didn't need the college. He was just doing it for fun, and he still happened to be good at it. Yeah, that was. I haven't talked to Troy McCourt in a long time. I don't know how he's doing. He was quite a bit older than me. He was probably, this would have been early 2000s. He was in his 60s, so he's probably in his 70s now. So he's an older gentleman, heavier guy too. So let's go look real quick and read the man on aid to see what it does. It's the Advanced Intrusion Detection Environment, and it says it's an intrusion detection system for checking the integrity of files, right? Like Tegrity Farms. Who knows what Tegrity Farms is? Who knows what that is? All right. Sock, you said you did a semester at ITT Tech. Yeah, I probably have books you learned out of then. If you were there from 09 to 15, that's when I taught there. And then I moved over to DeVry in 2016. I've been teaching there for 9 years, so 17 years total now. 17-ish years, right about 17. So here's all the stuff about aid, and I can see that there's some dry run and initialization of it. You need to initialize the database. Aid actually, Aid has like 2 or 3 STIGs for it, but we can't use it in like my Rocky environment or any of my Werewolf environment with my stateless nodes. And does anybody know why? If I have to initialize the database each time, and then the database, as you boot the server up again, wants to compare the files versus the database, well, that database has been wiped each time in my stateless environment. And now I could initialize the database down in the container image, but there's too many variables and too much difference. I probably really wouldn't want to do that. Plus, by nature of it being a container image, it's always going to be the same every time it spawns anyways. Does that kind of make sense? Like, within my environment, it's always going to be fine. So there's no reason for me to use aid in a stateless node environment. And we always get an exception for the aid STIGs in our configurations for customers, with government customers and stuff. So that's kind of big. Anyways, all right. So I hit Q, I come over here, and let's see, let's do more on Etsy, cron.daily. And what is this daily aid check that got dropped in here? This is doing something. It looks for systemd running, right? Skip if systemd is running, so we have systemd running. But then down here it says if script, then run aid, and it'll do whatever aid is going to do. Okay? All right. And it's, so if systemd is there, then it's going to just exit. So it's not even going to run on this system, because I know for sure that... Oh, run. That's definitely there. It's definitely a directory. So, all right, anyway, so it says, what does this attempt to do? It looks like it checks for systemd and then it exits. But if it can, it'll call this script. Yeah, user share aid bin daily aid check. And then if that script exists and is executable, that's an executable flag. So it checks for executability, and then it'll go and it'll run whatever this capsh is, and it'll run this tool, right? All right, so good. So let's just make aid do something for us. Let's see if we can just get it to work for us. I just wanted you guys to see that there's like configurations that are set, and it's going to try to do things automatically in the environment. That's all cool. but we want to see it run for us. So let's time aid. Time is a stopwatch that you have in Linux. You can run it. When I used to work in SCIFs, right? SCIFs are these things that are called secure compartmentalized information. When you work anywhere, and what you can't bring into a SCIF is one of these. Cell phone. Can't bring it in. Also, nowadays, you can't bring in your little, like, if you have, like, little walking things on your wrist that, like, track your GPS, you can't have those in there anymore either. Because then people know where in facilities you are, right? So that when that data gets leaked, then that's always bad. Well, anyway, so time, well, the reason I bring that up is I used to work with a guy who, he had been in these data centers since, like, the 80s. And he always had, like, a little carabiner. So where's sending? Is sending still around? So have you guys ever seen that thing? A carabiner is like that little clamp, right? And he had a carabiner to like a little fabric strap like this long that looked like it was part of a belt. And then it had another little like carabiner on it, right? So carabiner strap. So it was kind of like a little thing that he could put on his waist and he could flip it up like this. And he just had one of those cheap little 3-button stopwatches on it. And you might say, why did he do that? Because it would just hang off and like kind of like slap on his thigh when he walked around. But he would pop it up and like, because when you're at a console and things are flying by or you're booting servers in an environment, he would just stopwatch and time things. And then he would keep in his notes. So if you guys have ever heard me talk about like why when I'm doing something and my script is going to take like 25 minutes and I tell the engineers, hey, I timed this, it's going to take 25 minutes, go grab some coffee, come back. It's once you get to this part of it, you can just walk away from it. You got 25 minutes. That kind of, the amount of errors that saves, especially with junior engineers that aren't going to control C something after 5 minutes and go, oh shit, I got to call Scott. You don't want to get called, do you? So put your times in there. Anyways, this guy, he used to time stuff because hardware, especially like the old IBM, like the P595s, the big racks, they could take like 4 hours to turn on if they hadn't been turned off clean. If they had been turned off clean, they only took like 3.5 hours to come up. But those freaking IBM systems, they took a long time to come up in like the early 2000s. It was ridiculous. So anyway, so my point is, if I time this, then I can tell you how long it's going to take. It's actually really funny that I didn't do it in the lab. I don't know why I didn't put it in the lab, but how long did it take? And then you're going to get 3 different times out of your time command. You're going to get what's called the wall clock time, or I think it's called real time. And then you're going to get user space time and system space time. The user and system space time are time against the processor, whereas your the real time is wall clock time, what we call wall clock time. Let me just show you here real quick. I'll show you an example real quick of like, so on the Hammerbox, if I just say sleep 10 and I time it, I just time sleep 10. This is going to have exactly or very close to 10 seconds of wall time, real time, and then like no time against the processor, because what the heck was the system doing during sleep? Nothing. So it's, yeah, real user sys. But if I did something like this, if I timed like dd infile equals dev 0, and then out file equals dev null. Let's not even do an out file, and let's do block size equals 1024K, and count equals let's do 10 gigs, right? And we're just gonna throw that into bzip -9. I don't even know if I have bzip on the system. 9, and then throw that into dev null, right? Throw that into a trash can. Bzip's not there. Gzip. All right, gzip. Let that run for a second. That was probably way too big. I'm gonna add gzip, or add. Oh no, we have gzip, so that's fine. We didn't need bzip. That's probably gonna take a little longer, but when this gets done, if it doesn't break the system, this will come up with what's it called? You're gonna see a lot more real and sys time being used. Whole lot more on this box. Here, let's watch this one over here. Aid is still running. Aid's not done yet. Poor Aid, still running. Sending said worth going over monotonic and wall clock time if you have a moment to speak on it and have something to talk on. Yeah, I don't know really much about the difference of that. I can tell you that real time tends to be off of the system clock, so it's not affected by the, like if the processor's behind. But I think that may be what you're alluding to, but I don't know that much sending. I don't know much about monotonic. If that's like how the system sees things, because guys, by the way, systems can be very bogged down and be very behind on time. But when they use the system processor off the actual motherboard, that's in real time, right? That's real time always. By the way, that's still going. This took 4 minutes and 9 seconds. Move this over here for a second. So it said, how long did it take? How much wall clock? It took a lot of real time and then a lot of user time and not too much on the sys time. Only a few seconds on the sys time, right? Yeah, why we care about time on systems is this is like actually time being used against processors, right? Where's this at? Hold on. I've lost my thread, guys. Where's my other thing at? Here we go. Oh, so look, this took 1 minute and 34 seconds to chew up that 10 gigs, and almost all of it was in user space, actual system calls against the processor. In fact, if I were to do uptime, I would see that my load had went up in wait time for the processor. I think this box has a few processors. Yeah, 2. So it's got a few processors. So the wait time for those processors went up, although that's probably only going against 1. But anyways, so here we go. So we've got the hash. Yeah, wall clock versus system user time. So yeah, system and user time really is gonna be what loads up against your actual processor, right? And then you can have more time being used than actually is time, and then you're starting to have like runnable and blockable processes backing up, and that causes real problems on systems that don't have a lot of CPUs for sure. Why might you want to know this on the system? Well, because I might want to put this into a procedure in the future for my junior guys, right? Hayes, I actually don't know the difference right off between monotonic and wall clock. I'm not sure exactly right off. I don't actually know that answer. Never decreasing or jump. I didn't think any clocks ever jump backwards. Time intervals like elapsed day between events. Okay. Like wall clocks, which can be adjusted for times. Oh, okay. I see. I guess I never really thought of it like that because I've always lived in Arizona. So all my clocks are monotonic. That's funny. So wall clocks can change because of time zones, but I've never actually thought about that because in Arizona we don't ever change times. We're monotonic by nature. That's actually really funny. Yeah, I didn't know. I never thought about that, but wall clocks do jump around, especially between systems. Which, I guess, to that point then, I am a huge fan of having everything on UTC and not changing. Like, if you're in a company that has, like some people here are in companies that are in all the time zones on planet Earth, it is very hard to deconflict times of an event happening if you're in different time zones. And most of my companies that I work in are in the US, but then the systems we run are all over the world, military stuff, that kind of stuff. And that's the kind of stuff that, like, I set everything to UTC, but when I was military, we used Zulu. Zulu for all satellites. We always did Zulu off of that. But yeah, UTC for my systems because I don't want to deconflict time. So yeah, I didn't even realize that's the difference between monotonic and that. So I did not know that. All right, so let's get this real quick. What do you notice about the output? Let's it says that it went and found a bunch of entries, 128,000. That's nice. And it wrote to varlib aid.db.new. So this is an interesting thing that happens. Aid doesn't overwrite the original database when you initialize it. There's a reason for that. What if there was already one there? Initializing it would blow away the one that was active, and that would be stupid. So you have to go manually do it right here. We're going to go set that database to be the aid database. They did that on purpose because they didn't want somebody to come along and write a script that just ran this tool, or you ran this tool for the first time and you didn't know that there was already a version of it. So they did that on purpose. That is on purpose. And if we do an ls-l on varlib aid, we should see those. Well, there's only the 2 in there, and they should be exactly the same file. We could hash them. So the size doesn't mean they're exactly the same, but this for sure will. If we did a checksum, that's exactly the same file. Well, we also copied it, but if we didn't know that, we would know that. So now I said, let's go test aid. Let's see if aid really finds little minutia and little dumb stuff that we can do. So I go to root and I make a dir called prolug, and then I maybe cd into prolug, and I make maybe test 1, 2, and then maybe I just write time aid-c etsy aid.conf. And then we'll let this check and see what the difference is between what's there and the time zone. That's funny, Hayes. There was a word. Does anybody here get Reader's Digest? I've been reading Reader's Digest since I was a kid, but me and the wife just recently signed back up for them. So much fun. She has tell you guys something funny about my wife. She's not in the States. She's flying back from Cheyenne, Wyoming right now, so she can't possibly be watching this. She's probably watching it on the Wi-Fi in the plane going, this motherfucker better not say what. I found out the other day that my wife doesn't like, I need to put this correctly. She doesn't think that I know very much. And I'm like, I told her, I was like, you're surprised that your husband, that's been a college professor the last 17 years, knew who Amerigo Vespucci was? Like, you didn't think I would know that? But anyways, where I'm going with that is, and you're going to like this, Hayes, because this is directly related to what you do and what I do in some ways. And the wife said, so we go to the back of the thing. I don't look at them until she tells me to. And there's this really fun thing, like these obscure words that people don't know what the meanings are. And I think there's 20 of them every time. And the wife's amazed that I get like 18 or 19 on it. And I don't count the ones that I guess. If I guess, I tell her just take the points off. And I think the last 2 times, because we've had the last 2, I've got like 18 or 19. But I've been reading Reader's Digest since I was a kid. Anyways, where I'm going with that is, Hayes, she didn't know a word the other day. So I was doing it. She does it first and takes all her letters, but doesn't look at it. And then she takes all my letters for choices, and then she goes and looks at it and grades them. Hayes, one of the words was staccato. And I was like, it's a short, fast struck note, right? It's like pop, 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 pop. Like staccato is a way that you play a note, right? And she was like, are you sure? Like, there's this other one that sounds really good. And I'm like, do you not remember that I grew up playing piano my whole life? Like, I've literally played concerts, right? Like, when I was younger. And she's like, oh, I forgot that about you. And I'm like, my wife doesn't even know me. And the parts she does know, she doesn't respect. Anyways, I thought you'd like that, Hayes. She didn't think I knew what a staccato was. It didn't say staccato note. It was staccato, and you had to, like, know what it was. Of course, yeah, staccato. That's... Anyway, yeah. My wife. Anyways, I'm like, did you really not think I'd know that? Anyways, it's funny. She's a good wife, but she's got her things. She doesn't think very highly of me. I'm just kidding. Anyway, so this is going to go, and it's going to check, and it's going to find that we've added a directory and files in our system. It's going to be like, I have no record of this. I need to, and it's going to give me the number of added things. This is super useful. If we go change things, it's going to tell us. Yeah. No, I'm definitely a nerd. She's got, like, I don't know. It's kind of funny. She just, like, it's almost like, I mean, she knows these things about me, but then it's like when push comes to shove, she's like, no, Scott wouldn't know how to do that. Like, what are you talking about, woman? Of course I know how to do that. Anyways, so she's pretty great. All right, so this lab's pretty much done. We really just have to watch the balance of this, and we already know what it's going to look like because we got this image over here. But this is valuable, right? Like if you've never set up aid or known that aid is there for you to do, you can really use this to just lay out. It's very much like how Tripwire was. It just lays these, it checksums everything in the environment, keeps a database, and just looks for differences. And it can run every morning. You can manually run it like I am. You can have it alert or look at things and send them up to, you can have it send those things up into Loki if you want to, right? Any of these tools that we use, you can do all this stuff. Yeah. Okay, good. So let's let this go. Yeah, Hayes, we don't play with daylight savings in Arizona. It's actually, so it's funny. So I was talking to somebody the other day, and I was like, yeah, we don't, deal with daylight savings out here in Arizona, but I work with NOAA, which NOAA is a very much an East Coast. I mean, NOAA is all the time, but it's very much run off of the East Coast time. And that's NOAA, right? National Oceanographic Atmospheric Agency. So I get on a call right now when I'm on call until this Wednesday. I'm on call for NOAA. In fact, I'm on call all weekend. That's why I've been sitting at my computer and not going anywhere. I get on a call at 5:30 in the morning. It's called the pre-ops call. Well, that's 8:30 for those guys. And then the ops call is 9 o'clock for them, but that's 6 for me. And then our first stand-up of the day is at 7, and that's 10 o'clock for those guys. So those guys don't even think of it as early. Then the thing is, people are like, well, Scott, like, it doesn't really affect you that much, because, yeah, it actually affects me every call all the time, because when other people shift, I don't. So the other half of the year, when like East Coast comes forward, or I don't know, whatever happens there, I'll only be, my on-call will be at 6:30 in the morning, so it'll only be 2 hours off. Such a hassle. And I didn't have to know any of that stuff when I was a kid. Now I have to know all that shit as an adult. It affects all my calls. And a lot of my, almost all of my company, almost all of the guys that I work with, work out of the East Coast too. So I got all kinds of early calls with those guys. All right. All right. So this will go. It'll show us that nothing's changed, or things that have changed, and that's useful. Ah, here it is. It's finishing up. See what it tells us. Oh, well, it's done something. Oh, come on. Okay. Took 6 minutes and 23 seconds of real time. And then it was 5:34 of user space time, right? So those are user calls and very few system calls as far as time goes. We come up here and we see that it did find that I made those the one directory and the 2 files. And then there was some caching stuff going on, but who knows what was going on with that. We could also exclude var cache if we don't care about that kind of stuff. But if we were nosy and we wanted to know when things had been patched, or data had been pulled down, like into var cache apt or something like that, we could do that. We could know when stuff was being pulled down. That's super useful. Right, but there's things that you care about, things that you don't care about. Our database has not changed, right? That kind of stuff. All right. So that's that lab. Then another lab that I did, and this one was kind of fun to me. Let's just copy link. If any of you guys want to do this lab with me, this lab has not changed since I first wrote it. I wrote this lab years ago now. When we first went over to Killer Coda, this was a pretty early lab that I wrote. And what this was for people that had never done a web server. If you'd never built a web server before, let me go here. If you had never built a web server before, I showed you how to build a web server in this other environment. You just Apache install. Your team wants like 3 different environments, and they want to go to these different environments on the same web server. So you choose to split them out by ports. They go to 80, I think 8080 and 8081 or something, or 8081 and 8082, something like that. Oh, here it is. Here they are right here. So they wanted these other environments stood up on your web server, and you go, okay, there you go. But then it says, this is funny. This is like one of the most true things I've ever seen as an admin or engineer in all my career. Your team was so happy with your work that 10 other teams have come and asked you to do the same deployment. Well, if you go and you do that lab, and you're down there and you're like one-off just installing HTTPD, and then you're doing all this stuff, you're very quickly going to find out that you're going to fat finger it, you're going to mess it up, you're not going to do it effectively across 10 servers, there's going to be just something wrong, you're going to have problems. So what I did was I said, well, why don't we just write a little Ansible playbook that does it, and then you could give me one server, you can give me 10,000 servers, I'll deploy it to all of them. I'll deploy it to this whole fucking company right now. No, I'm just kidding. All right. But anyways, make a web server available on Node 01 with these directives, right? So again, if what I do right now goes really fast and you want to go slow, you go up to this deploying a web server and you back up and you run at this. You go do the web server stuff and then you come forward to this. But anyways, gone are the days of the whole LAMP stack, right? We don't do everything on one anymore. Now we just have a web server, and then we have an application server somewhere else and a database server somewhere else, and 3 tiers of application, right? Hold on. Another thing, my wife makes fun of me for how loud I sneeze. All right, anyways, here. Let's check our host file. Here's our servers. Our web server, the one server that's going to get web stuff, is Node01. His environment is dev, and then his app is web. Control plane is just, we need to, something to do with their thing. Annoying. But anyways, that's the way that it should look right there. It's just something about the way that JSON pulls it in now. It's different than it used to be. Yeah, Hayes, it's always super loud. All right, so over here, let's go look at the answers file. We've got an answers file or an answers directory, and in here we've got a bunch of stuff. And that stuff, if we go look at it, is populated with, you know, maybe some stuff about dev index, and then there's some stuff around the maybe the virtual hosts that are going to be, or virtual directives that are going to define how the system gets set up. And these things, again, if they're a lot to you or you've never seen them before, in the other lab you actually go and write them yourself. Like I make you copy them and write them. This lab is going to do it in Ansible, so it's going to be much faster. But I already have them populated there for you. So let's clear the screen real quick. And let's just VI, or actually we'll just copy. Let's just, we'll look at it real quick. We'll VI answers web environment. And in here, we see that we're going to run against web servers. We're going to gather facts true, so we're going to get all the tasty information about the system. And then we're going to become true, but we're already root, so that didn't really matter. And the first thing we're going to do is we're going to have a task. So here's tasks. Each task is right here with the dashes. And this first task is arbitrarily named, install Apache server. Why do I say arbitrarily named? That could be called the blue task. And this could be the checkers task. And this could be the, I don't know, porta potty task. It doesn't matter what the tasks are called. It's arbitrary. But what it might matter to is us when we want to report this out to the customer. Like, this is exactly what it looks like. Like, I love this. Guys, one of my favorite things about Ansible, and I'm not saying this in a joking way or messing around, is that I could grab this output right here, just like this, drop it in ServiceNow, which is our change management system, or whatever our change management system is, hit save, and go to sleep for the night. I don't have to write up what my change did. There's what my change did. You're like, well, I don't know. That's what my change did right there. These were the servers that were approved. These are the tasks that I said I was going to do. That's proof of me doing it. I'm already in bed before the email even comes back to me saying, can you give me a little more information? No, I can't. There it is right there. Anyways, all right, I'm kidding. You don't have to be obstinate like that. You can just do your stuff. But anyways, we're going to install it. So here's our module, apt. And apt takes a few arguments. One is the name of the package you want to install, and the state, if you want it to be updated to the latest, if you want it to be present, do you want to delete it? So absent is to remove it. And if you need to look up these, there's a few ways to look them up. I really do like just going right to the documentation online. But let's say you're stuck down in a skiff and you have Ansible, but you don't have the web. You can go, right, Ansible docs, right? So you got Ansible doc -s, and the module was apt, and the module will come up and it'll say, here's all the options it takes right here. So right here, that thing that we saw earlier, and we don't need any of those. Those are all optional. We need name, list of packages, there's your name. And then right here, state, what do you want to do with the state? State can be absent. Where's that at? Here's state. State. Yeah. Indicates a desired package state. You can do latest. And you can do absent. I don't know why this doesn't have better. Anyways, that's what it is. Present, state, or latest, absent. Those are the ones that I normally use. Okay. So we've got that all configured. We've got that, we look through it all. We're going to create the directories, and we're going to use file path. and path is going to loop over item as many times as you say to loop over it. There used to be, and in fact in some of my Ansible playbooks, if you do all the labs, you'll see that I don't use loop, I use with underscore item. With underscore item is the old way of doing it in Ansible. The modern way that they recommend you do or request that you do or say that is best to do is loop. So now we get down here and there's a notify. So by the way, it's going to loop over dev, test, and QA. It's going to make var www.html underscore dev, HTML underscore test, HTML underscore QA. And then when it's done, if it comes out with anything other than okay, so if it's changed, it's going to notify the Restart Apache handler. All right. The name is going to do some modifications. It's going to do something very similar. It's going to insert with line in file in this path every time after listen. It's going to add in listen 8080, 8081, and 8082 because those are what are required. Okay. And then it's going to notify Restart Apache. Then we're going to have virtual directives, and it's going to restart Apache, notify Restart Apache. Then it's going to push some stuff over, HTML into each environment, and then it's going to notify Restart Apache. And then at the handler for Restart Apache, it's going to restart Apache 2. Now, anybody here ever seen the best example I can think of for this is kind of like if you've ever seen a bunch of hockey players. You guys ever seen a bunch of hockey players walk out to the ice from their locker room? Anybody ever seen this? And they all like smack the little thing that's hanging down or whatever or they all kiss their little whatever their mascot is. I don't know, whatever they do, right? And I always use this as an example because this is just how this kind of works in my head. If each one of them, yeah, some kind of ritual, right? If everybody walked into a room and the first person turned the light switch on, you have a light switch that toggles like this, and the first person hits it up, that's their ritual, right? Because something, whatever, so they hit it up. And the next person also hits the light switch up. And then the next person also hits the light switch up. And then the last person also hits the light switch up. Did the light ever come on more than it already was? Because all this is right here, the hitting of the notify to restart for the handler is just flipping the bit or the flag, however you want to think of it, the notify to on, and it's only going to restart Apache once, and that's at the end. It's not as each task runs. Handlers run after tasks. So all the tasks will gather up all the notifies. And by the way, this is super simple. This is one notify. Sometimes we have 30 notifies, and sometimes only 25 of the 30 get triggered. This is part of the cult of Ansible. Is idempotency is I can just keep pressing that button and keep turning that thing on, and it will not restart Apache unless it has to. Because none of these will change once my environment's set up the first time. But this lab is about configuration drift, so somebody's effing with our stuff and getting rid of stuff, and I'm turning it back on and just blowing over the top of it. That's actually what this playbook says. That's what this lab says. It's like one of your dev teams figured out that they could modify the testing QA environments because a previous engineer left them in the sudoers file. You can address that separately with the security team, but for now you need to get those environments back working. Somebody's complaining, something's not building, those dev guys are over there, they went to lunch, they don't even know how to fix it and turn it back on. So you have decided to just blow over the top of whatever config changes they did, and you're using this playbook to do it, right? That's what this lab is about. So you do the lab. The base lab is really just about installing the environment. So you copy that out and you run the playbook, and you're going to install the environment for the first time. Then you get to the end. We'll do the curl and we'll see it work, right? And I know for the security engineering course, this was a lot because we were not focusing on automation. But this is one of these things as an engineer, man. Sometimes you just got to pull up the big boy pants and do something that you've never seen before. You got to just go figure it out, like, because it's like that. It's like that old saying, "Nobody's coming, man. Like nobody's coming to help you. You got to do this shit yourself, right? You got to get this environment working." And we now have a working environment for curl. And again, if you want to see the individual components, you go to the other one. Okay. Well, that's what players. Yeah. Nobody else is going to win a game for you. It's one of the reasons I like wrestling. It's you and the other person. I mean, I don't want to be like one of those guys that's like, there's no more pure form of competition, but there's nobody else in there to help you. You got to beat that other person. All right, so anyways, here's solution for this. Originally when I wrote this, I wasn't going to give an answer, but this is going to remove, just for now, it's going to remove part of the environment from us. And don't worry, we add some blocks in there and do some other stuff in Ansible, but this is going to remove the test environment on 8081 from us. So this one says, make sure that it's broken. So 8082 still working. 8080 still working. That dev team ripped out 8081, and now people are screaming. Some kind of CI/CD pipeline is busted because that was maybe that 8081 was sharing every single package for your entire CI/CD pipeline. So now, for the last 2 hours, nothing has built in test in your whole environment, and your company has, maybe 300 engineers, and 50 of them are test engineers, and they haven't done anything but sit on their hands for the last 2 hours. Now, you might say, Scott, I thought you said only prod environments were highly critical. During the day, if you make engineers sit on their hands, you will find your company coming down on you like a effing hammer. It will be terrible. You will have, now look, it's already a sunk cost paying an engineer, but if you have engineers just sitting on their hands, not doing anything, and they're like, we know how to turn this freaking environment off. No, we can fix it. We fix it by running the original playbook again. So watch, this original playbook is going to blow over the top of those, and it's going to fix just those two things, just right here. You're only going to see the one node for test and the 81 come back up, and then you're going to see that it ran the handler and restarted Apache. And then if I ran this a minute later and nobody had turned it back off, watch, you're not going to even see the handler show up this time. Nothing's changing. Nobody's hitting the light switch up. We're teaching in a dark room. There's no handler run. Do you see that? The handler only happens, any handler only happens if it's notified by a task that was changed and not okay. All these tasks were okay. Nothing changed that had to notify for that handler. So that handler literally doesn't even show up. It would be right here. He doesn't even show up like he did up there. So all that to say, configuration drift is a major problem, and you might not think of it as a security problem. You might think of it as an admin or an operations problem, but the fact that these guys have the sudo permission, that's something security is going to have to go probably slap their hand and let me take from them. I could just take it from them, guys. But if I do that, they're going to say they can't do their job. So I have to have somebody in between this, right? Hayes, nice. Yeah, drop it on YouTube, put it up in the Discord. We like those things. So yeah, we ran this, and then there's a deeper challenge not required for the lab. This is another Ansible CSV report that I have, and that's a funny one. That one assumes that like people have lost the thread. They don't know like the environment anymore, and they need your help. And this actually, it's funny. This one came from an actual project that I actually had at a customer, where I went on a customer project to rebuild this team for a college in the Northwest, and one of the things that they asked me to do was, hey Scott, we don't even know all of our architectures anymore. They had this cluster that every year they dropped new stuff on it. So this cluster was kind of like, have you ever seen like when they put a magnet next to magnetic sand and it slowly swallows it? That's kind of like how I think of it. Like this cluster just kept going to new hardware, and then old hardware would just fall off the back every 3 years or whatever. So we had this Frankenstein's monster of like these different versions of the operating system, kind of operating system and underlying hardware with different ConnectX cards and everything else. So where I'm going with that is in this lab, I show you guys how to go pull a bunch of information and send it as a CSV report. And you say, why CSV report? Well, it's actually funny. My brother Tom came and talked the other day about data analytics, and what he didn't get into heavily that he talks to me about quite a bit is like how like the whole managers and everything, you could do all these other cool things and they will fucking still ask for it in CSV because they only consume Excel docs. They'll make you put it on SharePoint and then change it back over to Excel docs. And you're like, why don't I just give you an Excel, refresh cycle with legacy code for us? Well, for me, when I talk about code, I'm talking about operating systems and the drivers and stuff like that. That's the stuff that I care about, especially as far as versions go. The code and the other things that work on top of it tend to be, in my environment, researchers and dev engineers, right? But I tend to be the guy that keeps all their stuff. I'm a platform guy. I keep the platform stable, right? At least if you're like, well, Scott, where does all this stuff you know here, where does this all come from? That's where the place where it comes from, is from having done all that. All right, so let's pull this back up. We're almost done with all these. We're on the last one. This is the last one that actually has a lab involved with it. This one. So I got to make sure that we can do TLS. Okay, so this lab is rsyslog with TLS, and then I say review solving the bottom turtle, and then public and private key pairs. So, oh, I do have a lab on just that, huh? Okay. And then digging deeper challenge. There's some other labs that are not required, but they go and show you how certificate signing requests work in Kubernetes specifically, and then reading all the rest of the Solving the Bottom Turtle, which is a really great book that one of our community members wrote or was partially part of writing, and it deals with zero trust security. So if you guys need that link, here's that link. This is a good one. in the realm of free books, it's one of the better ones. So, all right. So, clear it up. I've been on this hammer box for quite some time. Yeah. I've been on here for a while. Hayes said I actually coded zero trust for auth team at one job. Nice. Yeah, that's valuable. Put that on a resume, because zero trust is one of those. That's a big one right now. That's a big one in the industry for sure. All right, so let's go pull up. Yeah, let's do it. Nope, I don't want to do that. We'll pull this up in its own shell. Go killer coda. And this one's going to be rsyslogging with TLS. So this one's going to be without the sitting down and talking about how TLS works. This one's going to be a little bit. It's going to be a little bit dry, and I'm just going to be clicking some buttons. But it says your team has determined that they need to centralize logging in their environment. This is a secure technical implementation guide requirement for government systems, right? And that's fine. Security, sure. Your previous step of rsyslog did not encrypt the traffic, so now we're going to encrypt the traffic with TLS between these two endpoints. Okay, we're going to set up certificates. So we're going to set up rsyslog for 6514, and the capture will be over TCP, and then we'll verify that rsyslog is listening on TCP port 6514, and then we'll go over to the other side and send the data. The graph of this, I have. Do I not have the diagram in here? I thought we had the diagram right here. Do we not have this diagram? Apparently I don't have the diagram in here, but maybe we'll see it at the end of this. I'm not sure. Thought I had the drawing for this. I definitely have a drawing for this, but I thought I had it up here. So, okay. Let's start with the things that are going to be needed for this to work. So we'll just install a couple of required things, specifically the GNU TLS and rsyslog with the GNU utilities. Or new, however you want to say it, I don't care. SSH node 01, and do the same thing as soon as this is done. Come on, system. Okay. Go over to node 01, do the same thing. And then the next thing we're going to do is we're going to go into the TLS directory and we're going to set those TLS certs up. As soon as that's done installing on node 01. All right, CD over there. We're in user local share CA certificates. So we're going to be our own certificate authority for this, meaning we're not going to trust some third party. We're just going to do it ourselves. that is not the way, and maintaining them on your own servers like this is not the way that I would recommend to do it. There are too many tools out there that'll do it for you. One is Vault by HashiCorp. It'll do it for free, although they do have the business source license, so it's a little different now. And then they're also owned by IBM, so a little different now. But they're still an excellent tool. That tool is excellent, but just expect it to be less and less open sourcey as we keep going, because that's the model of all these things. But the business source license says you can't use it if you're not paying them, if you're directly competing with them in that space, right? Basically keeps the cloud providers from using it, if you guys don't know. It's the same thing that happened with Elasticsearch. It's the same thing that happened with MongoDB, that business source license thing, and why, you know, companies had to remove them, because Red Hat used to use MongoDB for Satellite, and then they pulled it out in Satellite 6. So I was part of that. I was working with that when it happened. So, well, I was working with that as a customer. So we generated a key, right? So we're going to have a private key for the certificate authority that's going to sign all the other keys. This key, not going anywhere, not letting anybody see it. It's 600. I'll make this a little bit smaller because what I'm doing right here isn't super relevant to the overall what we're doing, except it's good to understand that I'm going to make a self-signed cert from that key, and I'm going to give it some information. I'm going to give it some defaults: country name, Providence, I don't care. Organization name we'll call ProLug, just for fun. And organizational unit doesn't matter. Common name doesn't matter. UID doesn't matter. DC and email doesn't matter. Serial number doesn't matter. But the days that it's going to expire, we're going to make 90 days, right? And does the certificate belong to an authority? We'll just go ahead and leave that at no, which is the default. And is this a TLS web client certificate? We're going to just hit no. We could say yes there, but it doesn't matter. Will it be used for IPsec IKE operations? No. And is it a TLS server? We're just going to leave them all defaults, right? But you do got to watch it, because right at the end, it'll say, it'll say, is this correct? And this is a lot more than I remember. Now, when it says, is it all correct, you say yes, and now you've built that. So we do an ls-l. We've got the one that we could share, and then we've got the original key that we can't ever share, right? What permissions? 600, 644. And now from there, we're going to generate a new private key for control plane. This is not going to be shared with anybody ever. And yep. And then from there, we're going to generate a certificate request. And we can accept all the defaults for this one as well. Seems kind of sus. I didn't think... Alright, fine. We're doing it live. Okay, so that's done. And then now we're going to sign the certificate. And then this one, we're going to have to put in some values. And we're going to, just for fun while we're doing it, I'm going to try to make this expire in 120 days. If the thing that I'm using as the certificate authority is for 90 days, and I set this for 120 days, so this expires after the thing that's its root authority, what do you think is going to happen? It's not going to work. So we're going to say no. Certificate will expire in 60 days. That's better. And then I want to honor all extensions? Sure. We can do that, sure. Does it belong to an authority? No. As a TLS, we can leave these all down the board. But now the DNS name, we do want to make control plane, because this is going to be required for when that other box talks to it, and that's how that box knows it, right? DNS name, there's no additional one, no additional URI. We can give the IP address if we care. We don't need to. Email, no. Nope. Nope. We're not going to mess with any of that. Leave it all on the defaults. And then is that correct? Yes. Okay. Here's some other things that you can set or whatever, accept all defaults. And then now we're going to validate the key. And in the key, we see that the DNS name for that is control plane. That's what we want. Okay. Verify all the permissions are like we expect. Sure, there's things that can't be read. and there's the things that can be shared far and wide, right? Also, did my thing break? Hold on. Hold on. That was busted. I don't like when that breaks. This, and where's my other one? Lab, right there. All right. So we got all the certificates that we need for right now, right? Yeah. So we come over here and let's copy the correct file that we need to over to node 01. So we'll copy that over there so node 01 can communicate back. And we're going to VI our Etsy rsyslog.conf file, and I'm going to hit Shift G to go to the bottom. Now I could modify the file right here for TCP, but I'm not even going to bother with that. I'm going to just shift to the bottom. I just like to throw things at the very bottom, and this is my custom config for all of it right here. My custom TLS server. I wrote all this a while ago. And we're going to use the NetStream driver GTLS. This will not work if you don't have those packages installed. This will not work if all of these aren't correctly set up. And the module IMTCP with the GTLS, that all needs to be there. We could have modified it up here, but I don't like modifying it in place, right? That's just too much. So we're just going to modify it down here at the bottom. Boom. And the port is going to be 6514, so we're going to hit escape:/WQ. And if everything's good, we should be able to restart our syslog. And if our syslog is running, that's a good sign that it's running. It won't run right if things are busted. That's kind of useful. And then we're going to come down here and look for 6514, and 6514 is being listened to for that is the any IPv4 address right there, and that is the any IPv6 address right there. So we're listening on IPv4 and IPv6. We are ready to catch traffic sending encrypted TLS data to us, right? Over that syslog 6514. So that's cool. Now we're going to go over to the node 01, and on node 01 we're going to make sure that we can send data back over that way. So we're going to VI our Etsy syslog. We're going to shift G to go to the bottom, hit O to go to a new line, and here's the TLS config that we need for that. Right? And I've included over here in the book, I've included the closest thing you'll find online to this. If you say, is this online somewhere? The closest thing you'll find online to this config I wrote is right, it might be in the worksheet. It's the original doc that I got this from and modified it from, and it's directly from the TLS maintainers, right? And they have a lighter version of this, but this is our version for this lab. So this is modified heavily from that original doc. You can look at the original doc and do it for yourself if you need to, but this one shows you how do we know the certificate authority file for the system that we're sending to. The action type, we're going to forward TCP to control plane 6514, and then all traffic coming out of our syslog on our side is going to be TCP. That's TCP, the double ATs. One AT is UDP, double is TCP on port 6514. Escape:/WQ. And if that's correct, we're going to go ahead and run our syslog here. And for fun, we can just go user add some user add -m some user, exit, and grep over here for, took a second, it's not there yet, grep for some user. It's not great. Hold on. Did I... Don't see it. Exit. Oh, I didn't want to exit. I want to go back to node 01. Hold on. Where's node 01? Did I not save that? Definitely saved it. Did I restart the service? I thought I definitely did. Let's add some user 2, 23, something else, who cares? Let's exit. Let's go look for... That's not good. Alright, let's see. Am I missing something here? CAPEM. all right. That's all right. I mean, I've gotten this one to work plenty of times before, but right now, it is definitely not doing what I want. So, hold on. Let's see. Our syslog is... Oh, it's having a problem. Oh, is there... Oh, can't read one of the files. User local share. Did I not set... I think I missed something back. Let's go look. I think I didn't set the permissions. Was there a chmod on one of these? I did miss it. There it is right there. I missed it. Now SCP it over. That's better. Alright, guys, that was my bad. Now we gotta restart the service. D. What? System CTL restart. Where's this log? Alright, we should not see that error now. That was my bad. I was testing you guys and... Alright, anyways, there we go. The other side should now be sending, and if we were to just on node 01 do some add users, and then we were to exit out, and then now we were to go look at our user. Now there's those some users getting created and thrown into our varlog. Should be varlog messages. Varlog auth-log. Yeah, so it's going into our auth-log in this server because that's where those things were being sent. Again, over TLS. Hayes, you like the new Superman? I haven't seen it yet. I've heard good things. I've heard bad things. I don't know. Yeah. So there we go. Yeah, I missed a step in there, so that was my bad. That's all working. Check. And then it says, "Look at you learning security." Ah, here's the original. Here's the original doc right here. If you say, Scott, where did that come from, and how close is what I'm doing to that? I would let you guys go and dig in on that more, right? What is that? Kind of violent, maybe not awesome for kids. Interesting. Wasn't there one of the Supermans where he was killing people? That was the Henry Cavill one. I don't know. I didn't really watch a whole lot of DC. I don't really watch a lot of Marvel either anymore, if we're being honest. There's just so much Marvel out there. All right, so this lab is done. We have validated that lab is good going forward, so then we're ready to move forward with our lab stuff, right? So that's all the labs. I've done all the labs today. If you watch the previous stream on YouTube, or if you watch this one and catch this later, I went through all the labs for the security engineering course that we have. Made sure that they all worked. Some of you guys that hung around, you saw me work through all of them. The only thing that I would tell you that you missed is to watch. There's like a lecture that goes with each of them. If you get into the book, which again the book is free, book's right here, free online. It has the links to when I originally recorded them. So if you want to go watch me from a few months ago recording them, it's all there. Yeah. No, Hayes, that sounds interesting. I just haven't had time. I haven't went to the movies in a while. And I'm on call until next Wednesday, so I won't be doing that. But the security engineering course, guys, this thing you just watched, if you hung out, this is free. We run it out of our Discord. We're going to do round 2 of it, starting up in, let's see. It's starting up in September, so the middle of next month. It's going to repeat every Saturday at 3 p.m. my time, which will probably be different your time. But you guys are welcome to sign up for that. We also have other talks and other things going on. They're all free. We have a 10 o'clock thing tonight for the Bash study group for people. Where's that at? I don't know. Oh, that's here. Yeah, there's a 10 p.m. We'll do some late night bash study, but I know for some of you that won't be late. So, yeah, on call. Yeah, everybody takes it at NOAA. So, there's no that's National Oceanographic Atmospheric Agency. In my unit, it doesn't matter what your job is, you take it. And that makes it only come around like every 4 months. So that's kind of nice. You take a week of backup, and then you take a week of the actual on call. So I was backup like last week, and then this week I'm on call until, yeah, it'll go until Wednesday. So as long as everything works, we're cool. No alerts, nothing to put in, nothing to complain about. All the lab stuff you guys saw me doing, you can see the diagrams for it, and you can see how it all works. There's also a lab that shows you how to build it all. So all of our stuff is, I mean, I try to make it as all as open kimono as possible, and that's just like an engineer, not even engineering, that's just a business term. Like everything that I do and everything I know how to do, I try to show you guys how to do, because I think anybody can do this. I think you just have to go spend time with it. We also have not just this course, but we have a Linux admin course as well, and the Linux admin course is 16 weeks long, and we just finished that, and I think we only had about 3 people that finished it this time. We had probably like 8 or 9 the first time, and that's out of like a few hundred that said they were coming, so a couple hundred that said they were coming anyways. So I'm not going to run that one again probably till January, but then we will run the Linux admin course again, because look, I think there's a value to like getting in base admin work, like doing Linux admin stuff, understanding the job and how you kind of get into the, I mean, anything to get you into like systems building and operations and maintenance and stuff like that, and it's good money in it, is valuable. Security engineer chat, not Bible study. That's fine, Hayes. Yeah. You probably heard, I don't know if you were in the talk earlier, the guys were sitting around being, I think some of them are like ordained ministers now or something. I don't know. That's like a fun thing for some people, I guess, to just go get ordained. But I've mostly handled all the things I wanted to do for today. We do have more stuff to draw and more stuff to work on. I do have more stuff to build out for you guys that are interested in, kind of like, I don't know, just in general how a lot of this stuff works that we work and build on. So we'll have some build streams in the future. I was planning on kind of going late tonight, but I'm probably just going to chill for a bit and get ready for that 10 o'clock course. It's not really a course. It's like a bash study group. If people have questions, they can throw them up. If people want to just hang out and talk, they can do that. One of them go become an ordained rabbi. Interesting. Yeah. So, all right. Well, we will call this good then. And I will, let me think. If there's anything else. Anything else we need to do? Anything else we need to announce? We've had really good sessions. Like the guys have been running, one of our guys, Sending, I don't know if Sending's still around, but he was running the, just kind of how interviews work. And he probably spent 3.5 hours with the guys today, just going over like interviews and getting people into, it's interesting. Like for me, like, I know the thing about an interview, right? Like, and I've been in a lot of interviews. He's been in a lot of interviews. There's 2 things you're trying to prove to a company, right? When we distill it all down, can you do the work and will you do the work, right? And I think most people pretty quickly can tell if you can do the work. They look at how you talk about things. They look about how you explain things, and maybe they even have you draw out some concepts and think through some problems, and maybe they put some little roadblocks up in your troubleshooting and then see how you react and that kind of stuff. And that's all like, can you do the work? I think is easier to determine. Will somebody do the work is harder, right? Because, once you hire somebody, then they're kind of in the organization unless they're like a contractor or something like that. But anyways, my point in all that is I think I can get you pretty far along with the can you do the work. But then when people get to interviews, like I've even talked to people where they're like, I just bombed the interview. Well, that's another skill. That's another thing that you got to work on. You have to, I was talking about kind of like this engineering hubris. You have to like know that like there's no problem that's going to come against you that you're not going to be able to overcome in some way. Like this was working 10 minutes ago. We can get it back to that working, right? Or somebody built this before. Operational troubleshooting is different than engineering troubleshooting because in operations you have the advantage that it was just working. In engineering troubleshooting, we don't always know if the thing we're trying to build ever will work, right? Like I'm gonna be putting Kali Linux in my Werewolf environment. I can't find anything online to do it. I can find Kali containers, but I'm gonna have to build them myself with Podman, add the things that I think they need, and then get them to stand up in my environment because we're gonna be doing a red team. We've already done this. This security engineering was all blue team and protective stuff, and then we're going to do a red team version so people can see how. Some people have never walked through a TAC.MITRE and never done all the steps of like a red team engagement. So we're going to do that. That's going to be the whole point of that one, because I mean, everybody thinks that like the thing over the wall is cool, but it's all still just work. It's all freaking work. You just got to find the work that you can stomach, man, and that pays you. You want to get paid too, so. I posit that Linux is a very good path to get into. And I tell you guys all the time, you don't have to do Linux just to do Linux. You can do Linux adjacent things. We had guys talking last week at the Linux group that were data analytics guys, security guys, like just straight security guys, systems engineers. We had all kinds of different talks coming in to show you that it's not just Linux, it's just the base, the foundation is Linux, So, all right. With that, I have talked literally all day, so I'm going to go and do some other stuff, and I'll be around down in the Discord and stuff, but I appreciate you guys all coming. I appreciate Sending Grounds helping everybody out with the systems and understanding how, how interviews work, right? Because, like, interviews, that'll get a lot of people. So,